Oh yeah, get down guys, get down. I want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. Hello, good evening, welcome to you all. It's been quite a while. I hope you're all doing well. I could have some cock-ups tonight because I'm running this through Google Meets. And then I think that if I click on one of the other windows to see what's going on, let's just try it. It's going to start screwing things up. Yeah, I'll have to be very careful about that. Now it's resized my window. Oh, great. Great stuff. Let's just try and get a couple of those things sorted out. Because it has been a little while, quite a little while. So if I pop that back to resize and then lock him in place, that should help. So, I hope you're all okay. I'll test that again. Yeah, I think that's all right. Excellent. Yeah, tonight I'm going to be having a chat with Flatzoid. Oh, I presume the sound's all right. Let me know if the sound's okay. I know you're going to say you can't hear me, even if you can hear me. Anyway, yeah, so Flatzoid. I'm going to be chatting with Flatzoid. Not really sure about what. We hooked up a couple of times, sort of planning this, and couldn't really decide on a subject. And then it was only, was it yesterday? Might have been yesterday, last night. I just dropped him a message and said, look, should we just stream? And he was up for it. So we'll have to see how it goes. Good afternoon, everyone here. Brian Pop Robson, Irish Dublin, not Iron. Pincho Paxton's Greatest Minds. Thank you, that sounds okay. Arwin says that I'm disgusting, says Charlie Welch. Oh no. What am I going to do now then? Eh? Screw it. Never mind. Yes, lights, camera, action. Mr. Andrew, doubtful form, observer, Cygnus TSP, What UK, FV peer review, and many more. By the way, I do have an apology to give. When I was setting this up, I had a look at my Discord, set up the IFTTT thing so I can see super chats come in, and found there's a whole bunch of super chats that look as if they were all came in at the time that I was doing a debate with, was it Kyle Adams? Yeah, I think Kyle Adams. Whether it's a debate or I think I did a premiere, didn't I, a little while back? But I wasn't around at the time, so I never saw any of those. I was hard at work. So my big apologies for all those super chats and my massive thanks for them. Excuse me, but I do appreciate them. So Flatzoid will be in about 1:15. Apparently that's when the electric starts in South Africa. What he does before then, I don't know. How he sets up his stream with that electric, I don't know. Perhaps it's coal. Who knows? But I did have a look at the side chat in his in his room waiting for this stream. He's showing an old video of his as some sort of not premiere, what do you call it? An intro. It was all about trilateration and triangulation. Why he's picked that, I don't know. Maybe he wants to talk about it, which is fine. But oh boy, some of the dumb that's being said in that side chat. Yeah. So certainly saying things like that I don't know that you have to use triangulation apparently for using a sextant. No. Saying that I'm dumb because I don't understand you need triangles. No. Mr. Michael Kahn is flipping his lid somewhat. Yeah. And I challenged him to a debate, and he then said, yeah, okay, we'll do it on Flat Earth Debates, or whatever the hell it is called, Nathan Oakley's thing. And if I don't turn up, I'm running away, and I've admitted I'm wrong. It doesn't work like that, Khan. Not at all. Yeah, I'm challenging Khan to a debate. We need to arrange where. I'm happy for it to be on my channel, but if you don't like that, it could be somewhere neutral. Or will you run away? Just showing that you're wrong. I suspect it'll be that. 81 in the house already. Massive, massive thanks and welcome to you all. I know it's been quite a while since we've done a live stream. Had a lot on. Always have a lot on. Yes, Watto. Khan! No, they can't understand the difference between triangle and trilateration, nerd alert. And I really, really don't know why. But there we go. He's insistent that GPS uses triangulation. No, that uses trilateration with 4 satellites, Mr. Khan. He doesn't get it. Just doesn't get it. Because you don't have the angles to anywhere. You just have a radio signal, or several. There we go. Gareth Dawson says that maybe Flatzoid's looking for some missing frames. Could be, could be. He might be able to find them when the electric comes on and he can see behind the sofa. Maybe they're down there. What happened to Arwin? I don't know what happened to Arwin. What's Arwin done? Can you ask Flatzoid if there are any pictures from space that are real? It's going to be interesting. Oh, and Peter Affinas. Hello, Mr. S. Greetings from Germany. Guten Abend, mein Freund. Did I just cock up my German? My schoolboy German. Mr. Nimrod was not in the credits. Well, Mr. Nimrod, my apologies if you weren't on the patrons list. It's quite an old video. I haven't updated because I haven't done a live for a while. I haven't updated it in a while, and it actually takes quite a while to update, which I'm happy to do, but I've not had the chance. So my deepest apologies, sir. Big round of applause for Dr. Nimrod. Yay! Oh, excuse me. Oh, what did you guys think of that I Can Control You video I did and the reveal? It was all for fun, just something a little different. I don't know what made me think of it, but I thought, oh, that'll be interesting. See what we can do. Something. Sorry, Clippy, says Watto. Am I Clippy? I don't know. Let me know. Let me know if this sounds okay. Google Meets. Did I? I didn't type Google Meets MEATS, did I? Somewhere. Oh, because I said Google Meets, yes. Oh, and I hope you enjoyed the piano music at the beginning. It's actually got 2 tracks, the sort of funky, weirdy one and then that ragtime. It just depends how long it's running and where it's got in the loop as to which it plays. I do like that one. Pincho didn't fall for it. No, and I suspect a lot of people didn't Pincho. But some people did. You know, and that's fine. I mean, that's the whole idea. We know that advertisers use all sorts of tricks, and FOMO is definitely one of them. You know, order now before we run out. Better order. FOMO. Lots of things like that. FE peer review enjoyed it. Oh, good. Oh, Nimrod, channel member or membership was just lapsed. Oh, I see. Okay. Yeah, because you got the little green star thing behind you, haven't you? Beside you, haven't you? Must be working. Yeah. Mr. SS. Yes, it's just one S. Mr. S, not Mr. SS. Yes. Where are we? Leo, your chemist. Question: if one puts a telescope in a weather balloon and tries to look at star space, would that be evidence? Oh, Mr. Flatzoid's coming in. Shall I let him in? Yeah, let's let him in. Let's let the guy in. Hello, Flatzoid. Good evening to you. Just to let you know, you are live already. Okay.
Yeah.
Cool.
How are you doing?
Yeah, not so bad. I didn't want you just to sort of drop yourself in it by saying something that you shouldn't say. That would. I'm just going to move this screen across a bit. How are you?
Oh, doing actually very well in yourself. Sorry, the power took a while to come on.
That's all right. You put more coal on. You're quite welcome if you wish to come on camera. If not, then that's fine too. Right now, you're just showing up as your logo thing.
Yeah, just showing up the logo. It doesn't want to work though. I think it's because I got my OBS on.
I got my.
OBS is on.
Oh, I got my. I think you might have to come into Meets first and then put OBS on because it grabs the camera. But I understand if you're already streaming live now, it's probably too late for that.
Yeah, sorry.
No
I'll
worries.
try that next.
No worries. No worries. So I was just saying, Zoid, that I was having a look at your stream while it was waiting. Mr. Michael Kahn is a bit wound up with me. But I think he's usually wound up with anyone who might disagree with him. Yeah, he's a bit wound up. Good evening, Mr. Michael Kahn. And I do challenge you to debate Mr. Michael Kahn, not on FED. It can be on my channel if you wish, or another channel. Hey, I'm even open to having a debate with you on Zoid's channel, if he agrees, with Zoid moderating. So I'm not running away. So you can let Khan. You can always let Zoid know if that's something you're interested in, and then we can arrange it. Would that be something you'd be up for, Zoid?
Anytime.
Cool.
Anytime.
Cool. Well, we'll leave that at that. So, was there anything in particular you wanted to chat about? Because I know I said as well that we sort of hooked up a couple of times and said let's do a stream, but didn't really come to any sort of agreement.
Yeah, we didn't have to give a topic or anything. Yeah, it doesn't actually matter to me.
No, not to me.
We always have nice. How can I put it? Chats that's nice and not triggered chats. So that's what I like about chatting to you.
Yeah, that's right. I mean, we can chat, we can disagree. I can call you an idiot. You can call me a fool, and that's and that's it. There's no nastiness there.
Yeah.
Yeah, that's cool. That's cool. Was there any reason? I saw that you had a sort of trailer video, an old one, where you. Yeah. Any reason you chose that?
Yeah, I just chose any one because it was one I had from you from a trailer.
Okay.
It was between that one or Mr. Egghead.
I don't know. I don't know that one, but I think that's what started it off in your side chat because they were talking about trilateration and triangulation.
Oh yeah.
And they were demonstrating a lack of understanding of the terms.
We can talk about that if you want to.
Yeah, we can do that. Let's start off and then perhaps see where we go.
Yeah.
Cool. Sounds like a plan. I have asked people in my chat if they wanted to super chat with any questions for you, if you're up for that, and I'm happy to do that the other way with any of your viewers who want to super chat you with questions for me or anything like that.
Yeah, 100%. Yeah, guys, just like he says, if you guys want to super chat to ask him questions, he's more than happy to answer, just the other way around as well. I think that's perfect.
Cool.
It's good to see your channel's growing so well.
Thank you. Mr. Oakley doesn't like it. Incidentally, I want to say congratulations to you. You are becoming the flat earther of prominence, or have become the flat earther of prominence. I'm sure Mr. Oakley's not very happy with that.
Well, I got my first sponsorship deal today. So I'm just waiting for the approval. Well, they've already approved. I'm just waiting for the video approval, and then it should be up Monday.
Who did you... I'm not asking who your sponsor is, unless you want to say, but...
I've actually got 2 in the pipeline, but the one's already approved.
What service are you using to get in touch?
No, they're getting in touch with me. I didn't even have to get hold of them.
Right, okay. Just be careful that it's not a scam one, because I get quite a lot of scam ones. Okay.
I do check,
Yeah.
No, I do know. I've got one already that I do background checks first.
Yeah. Okay. Right. So trilateration and triangulation. I mean, are you aware of a difference between trilateration and triangulation?
Yeah, trilateration requires 3 ping sources to a single observation source.
What's trilateration?
That's trilateration, yes.
Sorry, okay, it requires...
So let's put trilateration in terms of pinging. If it sends out a signal, it's going to get pinged, and when those pings reach a signal, it times it out, and how can I put it, from those 3 towers, it's going to give the pinged signal.
Okay, so you're talking about trilateration through the use of radio signals of one form or another, whether they're on towers, and because in effect cell phone towers could trilaterate.
That's how they use GPS,
Yeah, GPS trilateration, but that requires 4 signals. But all you know is timings to work out distances from. So you know you're 100 miles from this point, 500 miles from that point and 375 miles from that point, which could give you one crossover point. That's trilateration.
Yeah, that pinpoints the location, exactly.
Okay, so there's not any real disagreement there, other than maybe, I don't know, do you think GPS comes from towers rather than satellites?
Well, there has been ground-based GPS been around for years. The military has used it for many years.
Well, there's the, oh gosh, I forgot the name of it now. The Lauren and stuff like that.
Yeah, Lauren.
Yeah, but that was fading out. I think they might be reintroducing a different type of Lauren, but the original Lauren's.
I think it's Lauren E or something.
Yes, that's right. Because I think it was Lauren C. I think it might have been started about wartime, World War II. Yeah.
World War II used it.
I'm sorry.
I think it was World War II. They used Lauren C.
Yeah, because there were no satellites then. Okay, so I mean, it sounds to me like there's no big disagreement. Sorry, I'm having to muck around with my mic because it hasn't. I haven't been using this for a while. It sounds like there's no big disagreement about trilateration. So, what's your thoughts on what triangulation is?
It's a sort of a triangle that you're working out the three sides with different measurements. Like you're triangulating your position.
Excuse me.
From one observer.
Well, you're triangulating your position based on angles. For instance, if you're sat somewhere in, what do they call it there in South Africa? Do they call it the bush? Yeah, I don't know. Okay, you sat somewhere in a bush. You got a map, and you don't know exactly where you are, but you're looking around you, and you can see that due north of you, using your compass, absolutely exactly due north of you is Mount so and so. So you could see that on your map, and you could draw a line on your map from that mountain heading due south. You're somewhere along that line. Agree?
Yeah.
Yeah. Okay. You then turn towards the right roughly, and you can see at 45 degrees. I don't know. There's some other mountain, and you look at your map. You see where that mountain is, and you could draw a line exactly east-west. Not east-west, north-east. Yeah. So at 45 degrees off of north.
Mm-hmm.
And where
you're making a horizontal measurement. You're making from left to right measurement, the horizontal.
Yes. You've established the direction to the first mountain. You've established the direction to a second mountain, and where those two paths cross is your position. Of course, if you do it with a third or a fourth mountain, you'll get it more and more exact, which is triangulation.
Yeah, the more you do, the more exact it is.
Yeah, and that's not what you do with a sextant.
The sextant does use triangulation.
Now this
citation says so.
Right. Now, I would take an angle to a star. That's its angle above horizontal, isn't it? I don't want to argue. I don't want to argue specifically about whether you allow for curve or anything like that. But you establish a horizontal. You take an angle up, which gives you your angle off of zenith.
Yeah, it's an elevation angle.
Yes. Yeah, but it's not the elevation angle you actually use. It's the angle off of zenith you use.
Elevation angle, yeah. Zenith requires elevation angle.
Yeah, but you deduct if that star is at 50 degrees above the horizon, then you deduct that from 90 degrees to the zenith. It gives you 40 degrees. 40 degrees off.
From your co-altitude angle. That's why it's elevation angle.
Okay. So all that's telling you is going round a curve. The position where that star is directly overhead, you are 40 degrees around a curve. Then, if you know how big that circle is, you can know how the distance 40 degrees is. That gives you your distance from there. That's all it's telling you. It doesn't tell you what direction that star is. It just tells you you are 150 miles from the GP of that star. That's all it tells you.
Over a horizontal plane. Not over a curve, of a horizontal plane. The angle requires two straight lines, and to take it from an elevation angle, which means it needs a horizontal.
Right. I'm happy to talk about that, but that's not the aspect I was getting at right now. However you establish because you could get that co-altitude angle straight using a bubble sextant, couldn't you? You don't have to use the horizon. You're using your bubble sextant. Your bubble gives you your vertical, and you're seeing the angle down. In this case, 40 degrees to the star. So then we haven't worried about the horizon and whether there's mountains.
It just sets a new horizontal. It just sets your horizontal base. That's all. The bubble sextant.
Well, what we've done is we've established how far off of vertical that star is.
Yeah, but you do know plumb means 90 degrees.
No, well, plumb means vertical, but can we just try? I mean, I'm happy to come back to that.
Yeah,
I
but
just
the
want
vertical is 90. But that's what I'm saying. That vertical you're talking about requires a horizontal to make it 90 degrees.
If I hang a plumb line, do I need any sort of angle? I'm just hanging a plumb line, aren't I? It naturally drops straight down. The bubble naturally goes to the top of the little dome inside a bubble sextant. You have established a vertical through some means. Hold on, you've established a vertical through some means, and then measured the angle the star is off of that vertical. I'm not worried about how you've established that. So I'm happy to come back to the horizon thing in a minute if you want.
But can you show me a bubble in the bubble sextant, which is not over a horizontal? You literally every level in history requires that horizontal plane to have that vertical bubble.
In a bubble sextant, the bubble is in a slight dome with crosshairs or a circle or something on it. So that dome, a semicircle, the bubble's always going to sit exactly at the top. So you angle it until it sits exactly in the crosshairs.
So Tony Whitcomb gave £10 super chat. Sorry guys. Why do you need triangulation when all you need is a Baker Light landline phone to call the people on the moon? He's probably talking about.
I know exactly what he's talking about. President Nixon, and I saw someone discussing that recently, and they cannot grasp that phone call would be to some NASA facility, and they transfer the sound signal onto radio, which is broadcast, no doubt, through one of the big telescopes, radio transceivers to the astronauts on the moon. Well, it's radio. It's simple as that. It was radio. I mean, that's not a big deal. If someone telephoned me now and I put it on speakerphone, you're in Africa, South Africa somewhere. So that phone call has been transmitted via copper wires via a Wi-Fi type signal to this handset, broadcast to sound, converted to internet, not voice over internet protocol, but internet protocol, and broadcast. It's just a transfer of a signal. In that case, it was the sound signal transmitted over a telephone to a station and then broadcast to the moon. But that's getting off it. Can we? I just want to establish.
Yeah, back onto the topic.
Yeah.
But like I was talking about the bubble sextant, it literally requires that horizontal plane to have that vertical to exist.
But honestly, Zoid, I'm totally happy to talk about that, but I just want to establish a more general thing about sextants, okay? So you have established your horizontal, if you like, established a vertical, and the point is you have made a measurement of that star off of that vertical of 40 degrees, either by taking 50 above the horizon and getting the co-altitude angle, or measuring it directly off of it. If you've done it one way or the other, you've ended up with 40. That gives you 40 degrees of curvature from where. So if the star's GP is directly over here, my position is 40 degrees off of that. Now, if I know how big the entire circle is, I know 40 360ths of it is the distance I am away. That's all I know. So if you're measuring arc in the sky, you're measuring an angle, a degree. You're measuring.
It doesn't mean it's curved. It doesn't mean it's curved. You're literally measuring from straight lines.
Okay, you have measured.
Remember, the degrees are based on a 360-degree circle, just like a clock.
Yes. Yeah.
Yeah.
So if
the radius line.
I know. It's not an exact equivalent, but taking a clock. If I have a clock, a standard round clock, and I measure around the diameter, the circumference, and I get that clock as exactly 1 meter circumference. Okay. Now, if I'm stood at a GP at 12 o'clock, you're stood at a position, and you say, how far am I from that 12 o'clock? And I say, well, you're 90 degrees around the clock because you're stood at 3 o'clock, you know,
Mm-hmm.
because you know that the circumference is 1 meter, you know you are 250 centimeters, sorry, 25 centimeters. Oh gosh, my stuff's all
Yeah, and I get what
you
you're
are a
saying,
quarter of the
trying to-
way round the clock. That's all you establish with one sextant reading, how far around that circle you are. It doesn't tell you what direction. It only tells you are,
But you see, that's the thing. That's why we're saying you guys are literally hijacking perspective, because you're taking
no perspective.
apparent angular measurement. You're taking apparent angular measurement, which is due to perspective. It's giving that arc in the sky, like I explained to you. You did see that diagram that I've done before, where I show the measurements and why you get the distances from the equator to Polaris. That's why you have your quadrants.
Well, I'm not sure. If you've got that diagram to hand, you're welcome to screen share it.
Yeah, I'm going to quickly do that. I'm going to see if I can get it up quickly. How do we screen share, though?
Hold on. At the bottom, there's a box with an upward arrow. Present now.
Okay.
And I thought I saw a super chat come in on my channel, but right now it's not appearing in my IFTTT list, so I hope that hasn't dropped out. Just going to scroll back to see if I've missed it. Well, Dr. Nimrod's been a member for 3 months. His free super chat says 3 months, baby. It should be more. Thumbs up. Thank you, Dr. Nimrod. And David Oliver, member for 19 months, says, I missed you, Mr. Sensible. Glad there's a live stream. Well, thank you very much, David. Right, I think that's coming up. Am I? Oh, gosh. Okay, I think we got it.
Yeah. Okay, I'm just going to skip through this till we get to the point where it's showing everything. There we go. And then I'll explain it quickly. You haven't seen this before, have you?
I think I have, but I'm welcome. I'm very happy to sit here and have you explain what we're looking at.
Okay. Yeah, well, anyway, this would be like the observer on the equator.
Yep.
And this would be Polaris. So in other words, it works out to 5,400 nautical miles. So on your globe, it would also work to 5,100 nautical miles. But that is because of the degrees. It's literally you're taking your 90 degree, which is the vertical, the GP, and you're minusing what you've measured. And that gives you the co-altitude angle. And then you're timesing it by 60 degrees. And that gives you your in nautical miles, because you're working out a full clock. And that's all. It's literally working at a quadrant of a circle. And you guys take that measurement of apparent altitude measurement, and you just timesing it by 4. So you're going to have a full 360-degree circle. But in the meantime, you're literally only measuring this full 90-degree quadrant, because you can't see behind your back, obviously, and you can't see under the ground and whatever. So you guys take that apparent angular measurements, and you've taken it now, and you're just begging the question that it's curving the surface. In the meantime, the surface is still flat. It's just due to perspective that it's dropping in apparent angular size, altitude.
Sorry, can you just make your diagram a bit bigger so it will show up clearly on the stream? Sorry, is that possible?
There we go.
Thank you. That should be a bit clearer for people. Okay, so your longest distance is when the star is at the horizon, 90 degrees minus 0, because it's 0 degrees altitude, giving you 5,400 nautical miles.
Yeah.
Okay. So what happened if I move 10 miles further away?
Then you're not going to be able to see it. Because
why?
It's
yeah, go on. Sorry, I interrupted. Go on. Explain why.
Because it's already gone to the horizon. How are you going to measure it if you can't see it?
So why won't you be able to see it any further?
Because it's already converged into the horizon. That's the convergence point. As soon as it's converged into the horizon, which is now, that's the limit of what you would see Polaris from.
So what if you used a telescope to see it then?
How are you going to? What's a telescope going to do to?
Well,
bring it back?
Well, I'm saying why is it converged due to your eyesight and
perspective? Yeah, perspective, because things do drop into the convergence because of perspective.
Right, there's a couple of things. There's a couple of big questions I've got about this.
I want to see quickly if I can. Back. Oh, sorry. I want to see if I can get it back to that. I'm going to start it to where the, because you see this dome thing I'm showing there.
Yeah.
Okay, let's do it this way. This is now, because you got a field of view. You got a limit to your field of view. And obviously you got a 360 field of view around you kind of thing. So this is the observer standing under Polaris at 90 degrees.
Mm-hmm.
So his maximum would be that 5,400 nautical miles from him. And as he's moving 600 nautical miles away, his apparent angle that is measuring now is at 80 degrees. It's not literally dropping 10 degrees. But on the globe, you guys are assuming it's literally dropping. But it's only an apparent altitude measurement. So if you had to walk and that's just following his field of view bubble. So as he walks further away, it's following his field of view bubble, and that's why it's dropping, because he's limited to that field of view.
Okay.
And that's why when he gets to the equator, it's on the horizon.
So
if he gets further than that, it can't see him.
I have a couple of big questions about this diagram of yours. Can you leave the diagram up again? Is that all right? So I can just point out a couple of things.
That's fine, but I got another super chat.
Okay, yeah, go on. You do your super chat, but if you can then bring the diagram back up, go ahead.
Okay, sure. Tony Whitcomb, £10 super chat. Mr. Sensible, as you live in the north and water is level at your point, do you believe at the equator the water level is vertical from you?
I know what he's saying. If I was at the North Pole, is the water at the equator like that? Yes. Is a simple answer. And in Australia, it's 100% the other way up. Right, okay, going back to this diagram, I've got a couple of questions. You see, you got your guy at 0, and you got the guy in lime, I'm a bit colourblind, lime green or whatever, at 600 nautical miles, okay?
Okay. Yeah.
So they are 600 nautical miles away from each other, yes?
Between each one is 600 nautical miles.
Okay,
away, yeah.
So look at the yellow guy at 3,000, and whatever colour it is, the guy at 3,600. Your legend says they're also 600 nautical miles apart, but the diagram shows they're actually closer together than the other two. I.e., the further you go. Sorry, if I just finish. The further you go, the lower that star appears. Your 600 nautical miles is changing actual physical length. Why?
No, it's not changing actual physical length. I was busy showing how you would draw it, because remember, orthographic view doesn't take perspective into account. So that's why I drew it this way, because you can see it's showing the compression further as it goes away and further the top. I mean, just like it's compressing, the distances are looking to compress further to the equator. On the top, look at even the top there by Polaris. It's having the same kind of effect. And that's why this bell curve, I would put it, is giving you guys your sphere. Because it's just literally inverting your guy's sphere. Because it's all just optical. I drew it this way on purpose to represent perspective, because we all know orthographic view is not perspective based.
Well, for each of those guys, the angles they're looking at towards the right at 10, 20, 30, 40, 50, I'm presuming, is that just hand drawn, or are those the real angles?
Real angles.
Okay, that's cool. Okay, so if those are real angles from each of those observers to the star, then why is double the angle not double the baseline?
Because I drew it as perspective. If I had to draw it with, let's put all the things just at the same distances on the timeline as you guys want, it's still going to give this, but it's not going to show the compression as I was just trying to show. That's the only reason it was drawn this way, because I was trying to bring a perspective kind of view into it to show it's just converging and compressing in the distances. It's the only reason I drew it this way.
But you have a problem in that if you've got 90 degrees at the bloke at 0, the guy at 0, he's looking straight above his head is the star. Then for each of those, you have an angle to that star, and you've now got a known distance to that star. So that means you can work out the height of that star.
But it's only an apparent angular distance. It's not an actual.
Sorry.
See, this is the difference. When we look at the stars, we're saying it's only apparent angular measurements. You guys are saying it's physical angular measurements. So you guys are literally believing the star is dropping those degrees.
Well, that's exactly what your diagram is showing. Your diagram is showing that they're dropping.
No, it's an apparent angular drop. Remember this dome thing kind of I put here is showing the field of view. These things are following that field of view limit. So it's literally following your limit of vision. Remember, the radius from the guy from here is the same radius to there, the same radius to there, the same radius. If your limit is 5,400 nautical miles away, let's just put it. That's your limit of vision. You can't see further than that.
Okay.
Now it's going to follow that 360 from you.
Your guy at 0, let's say that's you at 0, and the star in question is directly over your head, somewhere in South Africa, okay? Well, if you can just enlarge the diagram again.
Okay, I was just trying to look if there's more. Okay. Yep.
Right, so you're at 0, and I'm at 2,400 away. Following that whatever colour line it is, that suddenly seems to go through this limit dome to reach where it says 50, where the star is directly above you.
No. Let me show you again. I'm going to go back to where it started. Okay, let's put it again. This is where the guy is. He's under Polaris now. So this would be me.
That's
under
you.
Polaris.
Yep, that's you.
Yeah, that's my limit. You see there, Polaris is now hitting the top of my limit.
Okay.
That radius to the circumference of my limit is hitting that.
Okay, and I'm the guy at 3,000.
Yeah, so the next guy's walking. My limit is still there at that 90.
Yeah, okay, I've no problem with that. You can still see the star. Yeah, and you can still see the star. And there's me. There's me.
You see 40 degrees.
But that star's dropped down.
No, look, that radius line there is the same radius line to there. It's the same distance.
But why?
Following the arc of your that's how a circumference works. You understand the radius from the center to the circumference is the same at every degree, correct? The distance does not change if the circumference is the same.
Yeah, but your star's getting nearer to you then.
It's not. But in appearance, because remember, it's following the same arc. It's following the same arc. It's got exactly the same distance that it was there to there. Just like my distance to my 90 on top of me is showing the same distance from you to the 40. It's the same radius. The radius is a straight line to the circumference. It's only given an apparent drop because you can only see in a maximum 360 degrees. That's how your vision works.
You say
that's how your vision works.
You say we can only see a maximum distance. So following that line from me at 3,000 up to where it says 40 degrees, what if there's another star next to that is further away? So if there's another star next to, I don't know what that star is, above your head at 0 in South Africa, it doesn't matter. But if there's another star, so if that star is 100 light years away and the star next to it is 150, I can still see them both at approximately 40 degrees. Why should there be a limit? What's stopping me seeing that further star?
How would you know it's further away, though?
Well, I don't know that it's further away if I just look at it, but we know that stars are all different distances away, don't we?
That's what you guys believe, yeah?
Well, we know that they are. We can do things like parallax, angles of parallax, to calculate and show the distances to stars, to some of the nearer stars anyway.
Yeah, and parallax is all just optical.
It's different angle. It's the old finger thing, isn't it? Hold a finger and open one eye or another. That's giving you two angles, and if you know if you got a background, you can then work out the distance to that finger.
I got another super chat. Sorry, man.
Yeah, I've seen it. I've got them coming up from your stream. And guys on my stream, please, if you have any questions for Flatzoid, please pile them in. But go ahead.
Yeah,
go ahead.
$10 super chat for Godzilla37. Thank you very much. Mr. Sensible, don't you find it odd that despite it's what you're standing on, despite that it's spinning, despite that we're 7 years into it now, that still not one glow proof has been brought forward?
Oh, doesn't what Godzilla 37? Don't you actually watch debunking channels to see all the evidence? I myself did an experiment called Mage to show the curve of the Earth, and I filmed it. We've
But
got we've
Nate
got
didn't show curves there.
we've got a Foucault's pendulum that the precession varies dependent on your latitude north or south of the equator. There's another proof, another evidence. Sorry.
So are you getting what I'm talking about with your field of view vision?
I know exactly what you're talking about, Zoid. I was letting you talk through it because I don't want to, I don't want to straw man you at all. I don't think there's any need for that. If I misunderstand something that you're saying, then it's because I misunderstood something you're saying, not because I'm deliberately trying to trick or anything like that. There's nothing wrong with orthographic view. If you took a diagram, I could draw a picture of you stood in front of your house, okay, a distance away from your house, just an artistic picture. That's one thing. And perspectively, let's say you are 50 feet in front of the house, you would look comparatively large to the house due to perspective. That's fine. You could take an orthographic, you could make an orthographic diagram showing the height of your house as whatever it is, 15 meters high, including the top of the roof. The height, the height of Flatzoid, so many meters away at 1.8 meters tall and whatever. That's all correct. So if someone was laying on the floor, looking up at an angle and could see across the top of your head that exactly in line with the roof, that was shown on an orthographic view. It's accurate. There's no problem with that. There's nothing wrong with an orthographic view. It's not what you would see exactly if you were stood to the side, but it's diagrammatically and with all its measurements, it's correct. Those angles are correct. The heights are correct. The distances are correct. And that's why your diagram with the star and people at different distances doesn't work, because for every 600 nautical miles, your guys are actually getting closer to. They're not as far apart as they were between 0 and 600 as they are between 3,000 and 3,600. The star is dropping with an angle because you have forced the curve into the sky over a flat surface. If you made that surface curved, what do you end up with? You end up with everyone looking exactly the same parallel direction at that same star. They'd all be looking directly up your screen. That's your angle around a curve. Boom. That's how a sextant works.
But you'd have different radiuses though. Sorry, Godzilla 37, another $5 super chat. And original Zeros, this is the $10 super chat saying nothing. But Godzilla 37 says, did I say evidence?
What's that? Oh, what did he say then?
Let's go back to what he said.
He said
his original was, Mr. Sensible, don't you
still not
find
one
it
globe
odd-
proof, he said. Yeah. Science doesn't deal in proofs. So, for instance, okay, I brought forward the example of my mage with video. Now, you may turn around and say, but I can now demonstrate that evidence doesn't count because you were using a wide-angle lens, and to debunk my evidence. But then I can say, but look, here's the camera, and you can tell it's not a wide-angle lens to try and counteract that. The point is, it's not proof, it's evidence. So I present the MP4 file to you, unedited. That's my evidence, not a proof. And you query it to try and debunk it. And then I get the chance to show why I believe you're wrong. But it's never proof, because there could always be something else. Science deals in evidence.
I just want to know, what science though?
Well,
I haven't seen science for the globe though.
Okay, I've got a couple of super chats.
But you got super chats,
Yeah, I've got a couple for you. First one's a comment from April Van Ryn for $5 Canadian. Thank you, April. She says, we literally have a video of Jupiter rotating taken from Jupiter. How is flat Earth still a thing?
you begging the question that it's rotating from Jupiter. But you think it's rotating from Jupiter, but that's about it.
Have you ever used binoculars to look at Jupiter? Just binoculars, not even a telescope. Because if you look at it over a few hours, you can see the positions of the moons change. That's just with ordinary sort of 10 by 50 binoculars. It's quite astonishing.
Yeah, but it doesn't mean it's actually going around it. Have you guys ever seen someone can do illusions with flat disks and just place them going in the same plane in front of each other, and it looks like it's rotating around one another? Doesn't mean that sphere's orbiting it. It just has the appearance of that. Remember, when we look at something, we're thinking of things that are in the sky in what we would call like the firmament. So let's just say water's in the firmament kind of thing. It would be floating, in the waters, and they would just literally be just lights in the sky. Everybody comes from a different kind of mindset. The globe sees it as physical objects, in the vacuums of space, just magically floating there. We see it as optical illusions inside the firmament. So
Yeah,
I think
well-
that's where the trick comes from. Everybody sees it from a different point of view.
Well, for instance, with the moon, we can see craters that have been made by vehicles that have crashed into the moon. A few years back, there was Comet Schumacher-Levy, which broke up into a dozen pieces, and using orbital mechanics with all the various laws of gravity and so on, they calculated it was going to hit Jupiter, and indeed it did, and we could see the impacts on Jupiter for quite some time, more than one rotation of Jupiter, and the impacts came back round again.
That's interesting.
Okay, if you've not seen that, it's Shoemaker.
I haven't seen it. Yeah, I'll have to go and look at it.
Shoemaker, spelt as you'd think, hyphen Levy, Levy. Okay. Shoemaker Levy. It was quite astonishing. I do have another super chat from Mr. E-Man. Thank you, Mr. E-Man, for $50 Australian. Thank you, my friend. It's going back to your diagram. How does this explain in any way celestial navigation? When you take sightings of 3 stars, multiple rates of compression would need to be included in the calculations for celestial navigation. Where are these calculations?
Just like your globe, it's exactly the same. Don't you have different declinations and stuff according to your almanacs? It's the same thing because it's a different apparent altitudes. But remember, your measurements are based on elevation angles, which is flat. You need 2 straight lines to have an angle. That's what an angle is. I got another one for Godzilla 37, $5 super chat. Don't care what science deals in. Proof of shape is measurement in the realm of geometry, needed before Sputnik's first orbit, and must be exact. So he's literally saying we're not talking about science, we're talking about shape of measurement.
Sorry, I'm just trying to find his super. I'm finding his super chat so I can read it rather than yeah. Don't care what science deals in. Proof of shape is measurement in the realms of geometry, needed before Sputnik's first orbit. Well, I mean, they knew how large the Earth is. We know the pull of gravity, and so if you've got, you know what orbital velocity you would need at what height in order to maintain an orbit. If your velocity is too high, you will go whizzing off. If it's not high enough, you'll fall back down again. Get it just right, and you will continue to miss the Earth at exactly the same rate and keep going round it. And incidentally, I was thinking about that the other day. People talk about the moon landings and say, oh, they're fake. And people say, well, hold on, wouldn't the Russians have called us out on it, called the Americans out on it? That goes the other way round. When Sputnik went up, the UK, America, and plenty of other countries would have loved to have said, look, they're faking it. Here's the evidence to show they're faking it. And when Yuri Gagarin went up, that was a game changer. What a massive win for the Soviets back then. You know, at that time, I think it was at that time, you had McCarthyism and big hatred of communism in the United States. So if they could have pulled down the Russians and embarrassed them, they'd have jumped at that like a shot. But no, it was undeniable.
Politics.
Yeah, there was politics, but the politics helps actually evidence that it happened, because the political opponents first the Americans against the Russians, and with Sputnik and Gagarin, and then the other way round with the Russians against the Americans with the Apollo moonshots, they would have loved to have ripped the other side to shreds. Hey, we don't have to spend any money because we can show that they're lying. That would have been a massive win. They didn't do it, though.
$5 super chat from Godzilla. I think he also wants to debate you.
I think he's got a thing for me. Yeah, go on.
You don't have it. No proof. Images of Jupiter to fools. End of.
Don't have what?
The proof.
Is this going back to the shoemaker levy? Is that what he's talking about?
Because he says, remember, I think it goes back to the original where he's asking for the proof of the globe. So in other words, because you're stating it's evidence, it's not actual proof.
No, it is evidence. That's right. So if let's say if this is day one and I send up Mage, I've got some film. We say, hey, that's quite good evidence. That's one piece of evidence. What we need to do is have other people doing experiments, perhaps going higher, perhaps taking measurements to try and determine the distance to the horizon, perhaps using what's the word? I can't think what the word is. Where they measure curvature using the triangular excess, that sort of thing. But each of those things, any one of those things might not prove the globe, but it's another evidence for it. But then if you came along and said, but I don't accept that because, and here's some evidence that shows it can't be a globe, then we would have to go back to our drawing boards and either try and explain away your evidence or revise our opinion of what it is that's going on. And I think I've got another couple of super chats for you, mate.
Yeah. I just want to quickly say before that, you said RZA, zenith receptacle angles. That's what you're talking about.
Yes. There is that. Yes. And there's another thing. Not planar surveying. Is it geodesic surveying? Yes.
Geodetic surveying.
Yeah, that's the other thing I was thinking of. Right, so Mr. Flo Rider, good evening, Flo. €5 has got a question. Stars move counterclockwise in the north and clockwise in the south, yet the constellations stay the same. Explain, Fail-Zoidberg.
Remember, you still got hooked on my video that time and you showed the demonstration of the chair?
Oh, my spinny chair experiment, famous experiment.
I want to show that quickly for everybody. Be able to bring it. I couldn't find the video. I was looking for it the other night.
I don't have it to hand because I can't remember which video it was in.
Yeah, that's the problem But anyway, that demonstration literally made the point why it appears to be going. It doesn't literally go anti-clockwise or clockwise. Just like
no, of course not. The stars continue to rise in the east and rise in the west, unless you're close enough to the poles. So you get the circumpolar stars, which never set. So if you're within, the closer you get to, well, as soon as you're south or north of the equator, either Polaris or the area around Sigma Octantis never set, do they? So you're south enough that Sigma Octantis would never set, would it?
Yeah, but it's quite difficult to see it.
I'm sure, but it would never go below the horizon, just like Polaris never goes below the horizon for me. And if I'm at say 50 degrees north, then stars further south than that, further away from the pole, will set and rise again.
Exactly. That's what I'm saying. It's apparent angular.
Yeah, but
just like my what's the name was showing that graph. If you're measuring a 50-degree apparent angle to Polaris, then you're on the 50th degree latitude.
Yes, but what I'm saying is I don't disagree that the stars go in the same direction, the same apparent direction, but the point is, for those in the north, those looking northward, all those stars rotate around Polaris, and looking south of the equator, all the stars rotate roughly around Sigma Octantis. Now, yes, one's
Star
clockwise,
rotates the
one's
same.
clockwise, the other's anti-clockwise. That's not. I don't really like doing that because, yes, it's clockwise and anti-clockwise, but that's no different than looking to the left or right at spinning wheels. But the point
they're
is, you've
always
got
going
2
the
points
same
of rotation. How can you have 2 points of rotation, whichever direction?
No, you don't. It's still going the same direction. It's just your perception of view that you're looking to. If I'm looking north, it's still going the same direction. It's just going right clockwise. If I'm looking south, it's just looking to be the opposite direction, but it's still going exactly the same direction.
Yeah,
It's just your perception.
I'm not hung up.
that you-
I'm not hung up about the direction
Yeah.
because
But that's answering that guy's question. That's all I'm
yeah,
saying.
but in the north, you could imagine them as stars wheeling round Polaris, wheeling round an axle of Polaris. In the south, they're wheeling round whichever direction, but they're wheeling around an axle of approximately Sigma Octanis. So how can they be rotating around 2 points, and yet those stars that are roughly at the equator, their constellations aren't being ripped apart? They're staying exactly the same. They don't. 2 stars in a constellation stay exactly the same distance apart all the time. They never apparently move further apart or close together. But if you're rotating around 2 points, they would have to.
Yeah, but that's the difference. You guys are seeing them as rotating around 2 points. As we're seeing it's 1 point rotating, it's just having the opposite pole of rotation to that point. So like if you have let's say you have a disk, I'm old record player,
Good. Yep.
and Polaris is in the middle.
Yep. Okay.
It's spinning clockwise or whatever.
Yeah. Yeah.
And you're standing now underneath that. Let's just imagine you standing underneath that. Miniature you standing on top of it or underneath it and just looking at it. You're looking now one direction, you can see it rotating one side, and you're looking the other side, it's rotating. It's still the same full disk, just rotating the same. But to your vantage point, it seems like it's having another set of rotation when you get to the south. This is what I was talking about internal reflections. Remember I was talking about, I don't know if you heard a stream I was talking about the other night when they're asking me, but why do the people in the south see the same stars? If you're in South America and South Africa at the same time, you see the same, the Southern Cross at the same time, because of internal reflections. Just like you have a light source.
Well,
it's the internal reflection.
I'm so glad that you used the example of an LP record, because that's an example I use. So the spindle of the record is Polaris. Okay.
Yeah.
So we'll get some Tipex and put a little dot of Tipex on there, and wherever I'm stood looking at that LP record, the stars are rotating around that Tipex dot of Polaris. Yeah.
Yeah.
Yeah. Now Sigma Octanis is somewhere out near the edge of that record. So if you put a dot on that record somewhere near the edge to represent the south circumpolar point, everything doesn't rotate around it. That still rotates around the entire record is rotating around still the single point of rotation, which is Polaris. You can't have a second spindle. You can't drill a hole in somewhere near the edge of the record and have it go round that at the same time as it's going round the Polaris in the centre. That's the big point. Never mind the direction. You can't have 2 points of rotation. You can't add a second axle to a wheel.
That's the thing. There isn't a second axle. It's just your the view, your perceptual view. You're standing and looking.
But it isn't, though. It isn't. If I was stood at the equator and looked east, all the stars come vertical. If I look to the west, they all set vertically. If I look to the south, they rotate in one direction around Sigma Octanis. If I look north, they rotate the other direction, but that doesn't matter, but around Polaris. So why is there a rotation point over the north and a rotation point over the south, but there isn't one to the east or west or any other direction?
Remember, looking at it from a flat Earth perspective, it's dome-shaped, you can say, the firmament.
So I'd have to look at it with my eyes closed then.
I'm just saying, based on the flat Earth perspective. So if it's following, you've obviously taken a glass bowl and turned it upside down before, and you've put a light just going from, it's going to distort it further to the edges, and that's why it would give that second point of axis rotation, just because of the internal reflection.
Well, I don't know what it's reflecting because the stars in the north are nothing like the stars in the south. I do have another super chat. This is from someone I haven't seen before, but welcome to the channel. It's someone called Flurfs Suck Balls. He super chatted £10. A focal pendulum killed poor old Mitchell from Australia. Didn't it just? Bitch made from Australia. Another flat earth fatality. Ask Flatzoid, and I don't know anything about this Flatzoid, but ask Flatzoid about his Captain Cook Antarctic circumnavigation comment he made the other day. So I guess no ice wall. So I didn't see that comment. I don't know what the comment was. Perhaps you'd like to expand.
They think you can't circumnavigate around something and be inside something at the same time.
What the?
It's as simple as let's say you circumnavigate a pool. You can be on the edges of the pool and still circumnavigate the pool because you're going around the edges of the pool. That's still circumnavigation. They think that's now not circumnavigation because they said, show me one person that circumnavigated around Antarctica. So I said, okay, Captain Cook.
Right.
So they're misunderstanding circumnavigation means it's not an Arctic wall or something like that.
I think the big problem comes that either you accept Antarctica as a continent, in effect a bloody big island, or as the fabled wall around the edge of the Earth. The big problem is either of those could be right, but the distance around the edge of the Earth is rather more than the measured distance around Antarctica.
Yeah, but you see, his booked log was over 60,000 miles. But obviously it was stopping at different countries and stuff as well.
Heading north to resupply and stuff like that, no doubt, yes.
But it was simply just a reply to a guy to show me... Oh, shit, something fell. Simply just a reply to show... has anybody circumnavigated? That was all. It wasn't me making claims. It was just literally rebutting his argument. That was it.
I'll tell you what, my IFTTT thing works. I did read Mystery Man Flow Rider. That was Flow Rider again. Flow Rider said about the focal pendulum and Captain Cook. That's it. Sorry, it's not very. No, that was Flurf Suck Balls. It's very confusing. The name appears quite a bit afterwards. There's another one from Woodwork Learner for £2. Why do flats have different explanations about the sun and the moon? What do you think the sun and the moon are, Flatzoid?
Frankly, I don't know. Just lights in the sky at this point.
Okay.
To be honest, it would be speculation if I have to say what it is, but it's definitely not a rock in the sky and a gas giant, because they both just go against natural observations. I mean, you don't see rocks floating around anywhere in skies, do you?
Well, it's an orbit. Orbit isn't floating.
You don't see gas giants in a vacuum anywhere.
Only we can look at Jupiter
and imagine it to be that. That's what I'm saying. You guys are begging the question as that even though it violates laws of nature.
Well, whatever your laws of nature are, we can film the cloud patterns on Jupiter. We can see sunspots. We can see the gas prominences that rise from the sun. We can see the sunspots travel across the face of the sun and then come back round again. And then we can use what do you call it? The word's gone out of my mind. Spectroscopy, thank you. Yeah, to identify the constituents. With the moon, we can see the shadows of the mountains and round the craters. We can see how those shadows move across and around as you go through the lunar day. And as I briefly mentioned, there are photographs of new craters on the moon where spacecraft have struck the moon, with before and afters. So it's not the moon is definitely not gas. As I said, you can see the shadows. You wouldn't get shadows on something that's self-illuminating.
If it's plasma?
What, shadows on plasma?
It can be a plasmoid. It can just be different densities of light. That's all.
Well, it's quite interesting you mentioned that, because a video I recently looked at, I was thinking of doing, I can't think of the guy's name, was talking about the moon being plasma. But then, right since the earliest drawings of the moon, the patterns of the seas, the mare on the moon, which aren't seas, the positions of the craters hasn't changed, which I think is quite a good trick for a ball, if it was a ball of plasma.
Michael Kahn, £2 super chat. Sun rises in the east, in the south. Game over.
Sun rises in the east, in the south.
Yeah, sun rises in the east, in the south. Game over. That means I'm in the south and it still rises in the east, just like it rises in the east for people in the north.
Yes. How can the sun rise south of east from your position? Well, actually, I don't know how far south you are, but
But yeah, it rises southeast from me and sets southwest.
always, or does it rise?
Obviously, it moves around.
Yeah, of course. But it moves both north and south of due east.
It's never north of me, though.
It's never ever north of you. I'd have to look at it on a map to picture it with a rough idea of where you are. I've got a couple more super chats. To see it in Flurf perspective, you need to see it with your brain closed. That was a $5 super chat from Mr. QTube, first name Fa. So I think that was that was a comment rather than a question. And then a $1 super chat from Brenda Debate saying nothing, thank you. And one from Godzilla37. Thank you, Godzilla. Appreciate the super chat. $5 Canadian says, can anyone in your chat or yourself ever show plumb bobs hanging and not being perfectly parallel? Should be easy on a sphere, but none of you can. Well, Godzilla, that's an interesting point, because if the Earth is a sphere with gravity, as per the model, then yes, plumb bobs distances apart would not be parallel. But this lack of parallelity would be 1 degree at a distance of 69 miles away. So if you are able to provide some sort of measuring device that will enable us to measure a difference of 1 degree from two plumb bobs 69 miles apart, I'll happily run the experiment.
A sextant.
Well, if you can see a plumb bob that's 69 miles away, I think I've got another big super chat. I think. Where is that? Or
it's showing a $50 up there, by
yeah, but that hasn't popped up in my IFTTT thing. Oh, I mean, I had one. Oh right, I just realised I've never knew that before. If you click on where it shows the dollar amount, you click on it, it goes straight to the super chat. I didn't know that.
Cool. I learned something new now. Thanks.
Yeah, so we both have. But that was actually the one that was already there. So why is it only just appearing?
Maybe it's because it's a big super chat, so it takes longer to go away.
Yeah, but it just reappeared for me. How strange. But listen, thanks guys for the super chats. I really appreciate them, and I'm sure that Flatzoid appreciates the super chats over his side as well.
Oh yeah, for sure.
Yeah. So I'm not sure where we got to on all that. Where did we get to? We were talking about the moon, sun.
And I saw Brenda actually wrote a message to you because of the one that didn't go in the super chat.
Oh, right. Thank you. Let's see if I can see that. Perhaps you could do me the honour and read out Brenda's super chat, which hadn't got typed. I appreciate that. I'm looking as well. I found it.
Yeah.
Okay. Could you please ask Flatzoid, where is the constellation Virgo right now? It wasn't the message wasn't included in the super chat. But thank you for that.
Sky. It's in the sky. How's that?
It's a little vague. It's a little vague.
I answered the question. So that's
you did answer the question. You did answer the question.
To be honest, I have no idea. I'm not checking the stars right now.
Oh, Bob the Science Guy. Good evening, Mr. Bob the Science Guy is in the house. Long time no speak. He's actually come up with a thing about that plumb bob thing, and very good point. Saying it's actually quite easy to test. Look at the GP of a star, go 600 nautical miles in any direction, and hang a second plumb bob. The star will deviate by 10 degrees. Boom. Which is the co-altitude angle?
Which shows my what's the name true then?
No.
Yeah.
it shows that you're 10 degrees around a curved surface of 360. Oh, hello?
But there's my
Oh, sorry, just presenting something? Let me
share
just...
screen, yeah.
Okay, you got your diagram back up again. It helps
That's-
if you can zoom in, though, so everyone can see it.
Oh, yeah. There we go. But you see, that's showing exactly that. They're hanging a plumb bob at every single zenith, apparently. It's still...
Well, the co-altitude angle would be the plumb bob, wouldn't it? But I know what you're saying. So at the lime green guy at 600 nautical miles, his plumb bob would be 10 degrees different to the one from the guy.
That's why I
at
measured
zero.
80. That's why I measured 80, yeah.
Yeah.
It's the co-altitude angle.
But then,
It's still on a straight surface.
yeah, but the
So it doesn't mean globe. It just
look at
means you guys are
the guys on
exploring
the look at the guys on
angles.
look at the guys on the far left, the red guy and whatever colour that is. They've virtually stood next to each other. They're not 600 nautical miles away. If
Look
you
at- and look-
if
look
you
at the
turned
90 and 80.
yeah, but I tell you
Look
what,
at
those
They're
guys.
also like vertical to each other. If I had to put them the same distances away, they will also be the same distance away there. I literally did this because I wanted to show perspective where you can't really do it in orthographic.
But
and
if
that's
you-
the whole reason. I did
There's
it.
two things you should notice about your diagram, though, Zoid. First of all, you've got that curve in the sky. I know what you're saying, but you've got that curve in the sky. Secondly, those angles, like those old pin and string pictures where you put loads of pins in and string some thread round, you've made with all those angles a nice curved line going from the red guy up to the star at 90. Do you see what
Yeah,
you've done? You've taken
That
you
curve
you,
is
you
a
have
current curve.
yes, but you've done that by moving the height of the star. If you kept the star constant and did those angles, what would you get? You'd get a curve under your feet. You've taken the data and you've just got it in effect
Yeah, but
180 degrees wrong.
no, that's what I'm saying. You guys are taking it and saying it's physically dropping. We
Well,
are
that-
taking what we observe in
Go on.
reality because we can literally prove, this is actual proof, that perspective is a thing and things converge into the distance. It converges, and that's exactly what is representing here. It's proved. You guys don't have proof that it's actually dropping. We can demonstratively prove that things drop an apparent angular altitude based on perspective, because you can literally do demonstrations with it, but you guys can't prove that it's physically dropping. There's a difference.
But you see, round a circle, for every 10 degrees, you're going the same distance around. For every 10 degrees off of the zenith that star is, you've travelled exactly the same distance physically around the curve.
No, you've traveled on a horizontal. Remember, you guys are taking elevation angles. An angle is two straight lines.
Right. Yes, we did start off there, and actually before
Yeah.
we and I'd like to talk about that. Before we did, I've had a couple more super chats. I've had one from Godzilla for £5 saying that Gorzilla 37 guy stole my name. We mustn't be confused. Thank you for that. And Mystery Man, $5 Australian, acknowledging 2 poles of rotation is a step forward for a flat earther. So I think he's saying, well done, Flatzoid. And then I've got another one from Godzilla 37 for $2 Canadian saying, other way round, Godzilla. Guys, listen, I think you should carry on this fight. Super chat, every argument, and we'll sort it out eventually. Yeah, you wanted to talk about the angles and horizons and whatever. And I did say let's talk about that later because I wanted to stay on point, but I'm happy to talk about that now if you want.
No, go ahead.
Well, what was it you were saying? We were talking about sextants and you were talking about horizons.
Okay, yeah, like I was saying, when it comes to the angular measurements, you would understand the sextant, you're doing triangulation, because you're using two.
No.
But I can bring up citations that show triangulation. That's what we've been doing this whole time. Even McTooney also said there's no triangulation, yet there's citation after citation talking about triangulation.
Right. If I'm looking, so I'll bring the mic closer. I'm looking directly at you, okay?
Yeah.
there's that Earth behind me. That's a slightly different angle. With a sextant, I could measure the angle between looking this way and looking that way. That's what the sextant does.
Horizontal measurements, but
You can turn a sextant sideways and measure the angular distance between two mountains. That's all a sextant does.
Horizontal. That's a horizontal.
Okay, you can turn it this way.
Use it vertical, but use it vertical when doing celestial navigation.
Well, the point is, you can use a sextant either way. You're looking at one thing and bringing the image of another thing, so it overlaps. That could be sideways, could be vertical. It doesn't matter.
Angle, you have elevation angle, which is a horizontal.
What output do you? When you've done your reading, I point the sextant at something. It could be a mountaintop, or whatever. I bring down an image of the sun or whatever else, and I read off one angle, don't I? I don't know how far away the mountain is. I don't know how far away the second object is, but I know that the angle between them, the visual angle between them, is 17.5 degrees. That's all I know from a sextant, nothing else.
But like my Polaris, what's the name? It literally, you would know the distance because every 10 degrees is 600 nautical miles away.
But you don't.
So you would have a distance. If you're measuring 80 degrees, that's why you have a co-altitude angle. So you literally already got your two sides of your triangle, and that gives you your other side.
Okay. I've got a fairly long room, say a sports hall or something. You're stood at one end, and above you is a light. All right? Mm-hmm. I walk so far to the other end of the room, take an angle from the floor at your feet to the light, and I can see that angle is 40 degrees. Are you saying that's, whatever it is, I'm now 2,400 nautical miles away from you? Because that's the angle to that light.
And that's a false equivalence, though.
No, remember, it isn't. It's exactly right. That's why one angle can't...
This is based on Polaris having actual distances to the equator. You can literally go and measure those distances. We know the distances between the equators, and that's why that math I put up there works so perfect.
But it doesn't. I mean, I'm at the other end of that sports hall from you. I can see the angle to the light that is directly at your zenith. I don't know how far away I am from you. Forget that distance in nautical miles. How far away am I from you? I'm 40 degrees looking at the light above your head. You don't know. You can't tell. And quite right, because there's not enough information. All I have is one angle.
Exactly. You've got one angle in the light. But with Polaris, like I was saying, you got more than one part of information for your triangle.
No, I have. Okay. Right. So I look at Polaris.
Because you literally have measured distances.
Yeah, but I go outside. I go outside with the sextant. If I go outside with the sextant now, have a look at Polaris, and it reads 40 degrees. What maths can give me a distance from Polaris? From the, GP of Polaris.
Okay, I'm going to do this again.
Yeah, please do.
That's why you got a co-altitude angle.
Yes. 40 degrees up, 50 down. Yeah.
I'm going to actually show this one again now. Okay. This is that math. It's literally...
Okay, let's see your math then.
There we go. It shows up right there.
Sorry, which one's that? 90 minus 40 equals 50 times 60 equals 3,000 nautical miles.
There we go.
Okay, but I was at the sports hall, and that light was 40 degrees above you, so it's 50 degrees off of my off my zenith. Yeah, therefore, I'm 3,000 nautical miles. What's the difference? All I'm doing is looking at an angle above a flat surface. Boom! And I'm not getting a distance.
The sports hall is not... It's a false equivalence to what we're doing here.
It's not. It's a flat plane. The floor is a flat plane.
On your globe, is there 600 nautical mile difference between latitudes, 10-degree latitudes?
Yes, because we know that we know the size, we know the circumference of the sphere, and we know how many degrees you get in a complete circle. Therefore, we know the distance of 10 of them.
And this math I put here is not a sphere. It's based on flat.
Why do you have degrees in flat?
because a circle, we are measuring a quadrant. If you have 4 quadrants, it makes a 360-degree circle. We're literally measuring arcs.
I wish I had diagrams that I could pull up to try and explain how, if you turn this the other way round, if you didn't presuppose a flat Earth, if you took parallel lines of sight, of light towards a star, if I turn around this far, I know that I've turned 90 degrees. So 90 degrees around a tiny circle here, or around a slightly larger circle, or a circle the diameter of the Earth. And that gives you your distance. I've got a couple more super chats come in. One from Extra J for $10 says, Flatzoid, why can't you pick a single elevation for Polaris on an orthographic diagram? Are you worried that it won't work, or you'll have to say perspective bends the path of light or something?
I did pick a single one. I literally gave more than one there. I gave one for every 10-degree latitude.
Yeah, but I think the point's making is that the elevation of that star was falling.
If you pick one, it's still going to give exactly the same results because of the math I put there. It gives exactly the same results. Remember, that radius to the circumference stays the same no matter where you're standing.
Well,
that's what determines your apparent angular measurement.
Well, whatever the height is above the flatzoid that was stood at the 0, so it's you got a star directly above your head. Now, whether that star is 100 miles above you, a light year, or 1,000 light years, doesn't matter. It's directly above your head. I look at it and it's 45 degrees. Suddenly, it's a lot closer to your head than it was. So either it has moved or the light has bent. Which is it? It's got to be one or the other.
It hasn't moved. Just like you're looking at light poles in the distance, how it seems to be dropping into the convergence. Exactly the same how it goes with the stars in the sun. I mean, I've actually done demonstrations with the light that shows it dropping like it's setting. But it's exactly the same thing. It's not actually physically dropping.
You think of perspective. I mean, you keep talking about perspective, and indeed, as I saw someone said, perspective is in your name. If you're crouched down right behind a car, okay, a couple of feet behind a car, you've got 2 rear tail lights a fair distance apart from each other. The car drives away, and due to perspective, those lights appear to get closer and closer. When they're right next to you, they're far apart. The car goes a few feet, and very quickly they're going together. And as the car goes further and further, maintaining the same speed, the speed those lights get closer and closer seems to slow down. It takes longer and longer. Why? Yes, they're getting closer. They're getting closer due to perspective, yeah.
But parallax, if you have a mountain that's 100 kilometers away, it's going to move a much slower distance in relation to something that's, let's say, 10 kilometers to you. If you have a mountain that's 10 kilometers to you and you have a mountain that's 100 kilometers away to you and you drive away, the one that's 10 kilometers to you is going to become small in angular size much quicker than the one that's 100 kilometers away. That's exactly the sun.
Yeah, that's perspective.
Exactly, and that's why it compresses into the distance. That's why you see it
but
dropping down into the convergence, as you would put it.
Yeah, but if you're stood beside a motorway, a freeway, if a car rushes past you at 100 miles an hour, as it goes literally past you, it's straight past you, and then it appears to slow down the further it's going. It's still going at 100 miles an hour, but visually it looks as though it's slower due to the distance, or the perspective. Yeah. But you're talking about looking at a static star and moving a distance away and the angle changing. I don't. Maybe we're.
Can I show you? Can I actually show you a demonstration?
I'll tell you what. Shall I say yes? But can I read out 2 more?
I was got a super chat, so you go first. It's fine.
Okay. All right. I've got 2 super chats. First is from Fluff Suck Balls again. Ask Flatzoid to read out the definition of circumnavigation. This should be good. Buffalo girls go round the outside. So
Good for
I
you,
guess the
mate.
two of you have had a bit of a bit of an argument about circumnavigation. Can you circumnavigate within, or do you have to be the outside of? And I'll be fair, I could probably get both your points. If you had an
Yeah,
Antarctic ice wall and followed it around on the inside of a bloody great circle, then I suppose technically you might not call that circumnavigating. But I know what you're saying. If you're sailing around the entire length of that wall with the wall in sight, I wouldn't have a problem with you calling it circumnavigating,
yeah, that's
even
exactly.
if technically it wasn't.
Because I'm
I would have a
circumnavigating all the
I would have a problem with you based on your fuel and supplies, because it's a lot further than it would be going round the outside of Antarctica.
Yeah, but like I said, I wasn't making any claims. I was just literally rebutting a statement he made. That's all.
And
But yeah,
okay,
you'll be circumnavigating all the land.
yeah.
Okay.
I mean, I know what you're saying. I know what they're saying too.
Yeah,
Um, I think it's a case of perhaps,
communication maybe.
maybe,
Or
or well, let's not bicker about who killed who. And the second super chat I got here is another from Mr. E-Man for $5 Australian. Angular compression is not part of the calculations for celestial navigation.
yeah, because you guys literally take perspective and you call it physical drop. So that perspective that we see in the distance is not in calculations because you just literally take what we see as optical and call it physical. That's why. And
But
compression is not physical; it's only optical.
but those stars are dropping at a constant rate of 15 degrees per hour, at least the ones that are directly towards the
Yeah,
equator. They
it's a
don't.
parallax.
Yeah, if you get an aircraft flying overhead, as like that car example I tried to give, which probably wasn't brilliant, when it's immediately overhead, it seems to get past you quite quickly. But as it approaches the horizon, it gets slower, or visually slower and slower and slower. So it's not going
Mhm.
across you at 15 degrees.
Remember,
Sorry,
remember what I was saying with that field of view bubble. If
right?
it's showing that it's going through the convergence, the radius stays exactly the same to what you can see. The star's still getting further away.
But I don't see
That's what's
why.
having
I
that
don't understand why
apparent
you're
drop.
putting a limit
That's
on what
why
you
it
can see.
changes. Remember that. Let's take another example. For instance, you got two airplanes.
Okay.
One is at 20,000 feet, and the other one is at 60,000 feet, and they're both exactly on top of each other, away from you, and they're traveling. They're still going to be staying on top of each other the whole time, but the one is going to be getting smaller in angular size quicker than the other one, but they're still going to be traveling at the same distance. They're still going to be looking to be traveling the same distance to you, but the difference is the one will reach the horizon quicker than the other one because of the angular size, the parallax.
Well, obviously, leaving
So what
aside
to
the
do with
fact that by the time they're getting that distance away, they're going to be very hard to see. You could have a
Yeah, but I'm just giving an
telescope or
example.
something, so assume you can physically see them.
Yeah, it's an example.
The one at 20, I'd expect the one at 20,000 feet to physically disappear around a curve before the one at 60,000 feet because it's above the horizon for longer. I mean, if as you said that they were directly above each other, following exactly the same path, going exactly the same speed, that in effect you've got a vertical line between the ground through the lower aircraft and to the upper aircraft. All you're describing there is ship hulls disappearing over the horizon first, and the highest, the one that's the ship's mast, the highest aeroplane, will disappear second.
Yeah, okay. Can I go on to my super chat quickly? It's
Yeah,
from
yeah, please
Godzilla.
do, please do.
Globezilla, guys. You should actually change to Go Globezilla. So it's gonna be easier. 35 Rand. Thank you. Got to even the battlefield, I guess. So thank you very much for the super chat. There's a rivalry going on there.
There is a bit, and I just had another kind chat, $10 Canadian from April Van Ryn. We orbited almost every planet in the solar system and mapped it. How is that possible with lights in the sky, and how come the sun gives more radiation? It says towards I guess is what do you call it? One of those autocorrects, towards Mercy and less towards Mars. I presume more radiation towards Earth and less towards Mars.
Like I said, it all depends on how you are viewing things, do you guys believe there's orbits? You guys believe they're physical things?
We can
You know
see orbits, though.
Orbit, yeah, but that's what I'm saying. You guys believe it's an orbit.
Well,
It doesn't mean it is an orbit. It just means you believe it's an orbit.
well, for instance, with the moons of Jupiter, either they're orbiting, or those little lights are moving from left to right to left to right, left to right over just a few hours. You can actually, if you can see Jupiter fairly early in the evening when the sky's first dark, you can see Jupiter as a very bright light, appears like a star. It does move during the year, which is why we have the term planet, meaning wandering star. But it's a planet. But you look at that, you can see several of the moons to the left and right of it, or depending on the rotation. You can see several of the moons to each side of it. So you can in effect do an instant mini map. You could draw a little circle and put, say, 2 dots to the left of it and 3 dots to the right of it, or whatever. Go back and have a look at that little map and look at Jupiter 5 or 6 hours later. It will have changed. It's that massive a difference.
Yeah, but the problem is now trying to demonstrate that you're on Earth. Where do you see things orbiting on Earth?
The
you guys
moon.
Are looking in the sky and no, I'm talking about Earth. You guys are looking in the sky, and because you believe there's orbits, therefore orbits, but you cannot demonstrate it. There's no demonstrable evidence for anything you guys claim. Only belief.
Well, hold on. Are you meaning do something to show an orbit occurring on the Earth? One thing orbiting another.
A demonstration, yeah.
Yeah. Well, you can't, because you're on the Earth. You're in a massive gravity well. So you need a bloody great object to have its own gravitational field against another object, which has to be travelling at a speed to hold it at an orbital distance around it, while ignoring the fact that you're in the Earth's gravitational field.
I get what you guys are saying. That's why it always comes to scale and everything. That's why it's like, oh, but Earth has the greatest mass. But that's the problem. You guys don't have any demonstrations.
Yes, we do.
To be able
Sputnik. There you go.
It didn't orbit anything.
Of course it did.
You guys believe the orbit. Where did it orbit?
You could pick up, it orbited round the Earth, and its beep, beep, beep signal could be picked up as it crossed the radio horizon to radio receivers all around the world. Even kids in schools were listening to it on the radio as it passed over.
And it could have circumnavigated the skies on a flat Earth too. So it's definitely not an orbit, as you guys would put it.
Well,
that's why I said
let's go with that for a second. If you were assuming that the Earth was a flat plane, and I'm not talking about mountains and that, a generally flat plane, and you've got Sputnik travelling above it, you can pick up the signal in South Africa. Now you can pick up the signal in South Asia. Now you can pick it up in America and whatever. That path on a flat Earth would not be a circle. And also, whatever shape it is, what is it going around? Because it's not powered. It didn't have the fuel. It was blasted up there. It achieved orbital velocity until its orbit decayed, and it would burn up. So how did it go? Why would it travel in circles? There was no steering or anything. From its point of view, it was travelling in a straight line over a curve. Where did its left and right come to steer it so it sort of crossed Africa and went up here? And so on.
That's still not making my point. Like I'm saying, you guys are not demonstrating your orbits. You are literally making claims that it's orbiting without actually having demonstrations for it. You're making a claim he orbited, but you're not actually demonstrating there are orbits that can exist, just like the moon. There's no demonstration that rocks float in the sky. We don't ever see things falling around another thing in the sky.
Right. Yes, we do. Right. A couple of things. First of all, it's not floating. It's traveling. Yeah, which is what the moon does. But have you not seen the news in the past couple of days about a meteor that was discovered by some amateur Australia? And I've got a feeling it might have been someone in South Africa. I'm not entirely sure of that. But it travelled, and its path, which is a parabola around the Earth, was actually closer than the orbital height of many satellites. It was a near miss. And that's happened in the past few days. There's a falling rock, if you like, a travelling rock through space. You could see it with telescopes. It's never been seen before. You take a couple of sightings, work out its path, apply orbital mechanics, which requires gravity, and you could predict whether it was going to hit the Earth or not. And thankfully, in this case, it didn't.
Very nice. But like I said, you guys still have not demonstrated orbits working. You can have your orbital mechanics or whatever, but it's still just working in your mathematical constructs. It's not actually demonstrating reality.
Well, I said about the comet Schumacher-Levy, due to orbital mechanics, they were able to predict it was going to hit Jupiter and the time. And I forget how accurate they are, whether it was to within so many minutes or seconds, but they predicted it, and then they filmed it happening. I've got a couple more super chats. April has super chatted again, saying 2 previous comments directed at me. I'm not sure which ones those are, because I can't see any earlier.
One looking at that, I just got a statement actually to you from PJ Cruikshank. £2. You said it sensible. Jupiter is a light in the sky.
Well, yes, it is. It's an object that's reflecting sunlight, and with Jupiter, we can film with the aid of very powerful telescopes. We can film the cloud patterns on it. We can film the spot. We filmed the turmoil in the atmosphere after the collisions from Schumacher-Levy, which shows it is an object covered in gas. I've had a couple more super chats. Mr. E-Man super chatted $2.99 Australian, saying nothing but nutter and word salad from the Flurf. So that's a statement. Sorry, that was Greg Cott, so I do beg your pardon. And Dora Unku, good evening, Dora, super chatted €11, saying, woohoo, Mr. S live. Oh, Flatzoid, I already had a dose of nutter and semantics from Hugh's stream. Lurking only, trying to catch a comet that has a predicted position based on orbits. Sorry, I do want to catch up on his, if I may. Ted Lacoca, $4.99, and instantly, Ted, I don't know if you caught any on the stream, I found a whole bunch of super chats from when I was debating Kyle, which I never received. I did notice yours was one of them. Thank you for those. They never got read. But this one will do. It says, can Flatzoid demonstrate here on Earth a setting sun within a dome?
Yes, I can.
A setting sun within a dome that everyone doesn't always see, and part of the flat world is cold.
Okay, that's kind of what the part of that world is cold.
Yeah, so your model's going to have to demonstrate the sun's movement and 2 poles, the ice poles.
2 poles. The sun always rises in the east and sets in the west. It doesn't matter which model you use, so that's kind of nonsensical.
Yeah, but can you demonstrate it with a moon to scale as well? I think. His next super chat for $1.99 actually expands. It says he asks us to demo our model while we're here on Earth, pointing out the fact that trying to demonstrate an orbit on Earth is impossible, just as what he was asking of you is impossible on Earth.
No, but we literally can demonstrate. I can do demonstrations showing how the sun sets. I can do demonstrations showing how the stars move. We can do demonstrations showing bottom-up obstruction on flat surfaces every single day. We don't get actual demonstrations of the globe things. We only get, we believe it's that, therefore that's how it is.
Well, I wouldn't mind us doing this again sometime about... I mean, we've actually stuck quite well generally to stars and celestial navigation. I've disagreed with you, but I've enjoyed doing this, and maybe we can pick another topic and do this again at some point soon.
Oh yeah, definitely.
Okay, definitely. So you got a video, child's play, how a sun sets on a flat Earth. Are you able to expand it just to make it clearer on my stream?
Yeah. Just literally showing it drops due to perspective. I'm not physically bringing it down.
No, okay.
Remember, like I was explaining with Polaris?
Yes, but as you're getting further away, it appears to be dropping slower and slower, and yet in your diagram it was dropping at exactly the same speed.
No, look how it's compressing. You can see now it's compressing more and more further away it goes in the distance. You see that distance is bigger.
Whoa, what's that? What's that?
There we go.
What's it just disappeared behind?
I just put a paint can there so it can show things having larger angulars, in front of it, like you would have an ocean or a mountain or a tree or whatever. Because you always get people, oh, but on a flat surface, it's always going to be seen forever. That's not true. But
So
the
what
point
about
in
your
this one,
flat ocean? If you're looking across the
ocean's not
Atlantic
flat.
Ocean, you haven't got those mountains or paint cans or
The
things in
ocean's
the way.
not flat. There's always bulges and waves and um, tides coming in and out. So it's
What,
always going to have.
high
Remember,
enough to
the
hide the
line
sun?
yeah, remember, the further the distance, the more acute the angle gets, just like I'm showing you. See how when it was closer, how high it appeared to me? Now I had a apparent angular measurement to it. Dropped in angular measurement just because of distance. It's still exactly the same
No.
height. It didn't drop in
What would
physical height.
be really be interesting is if you took that light and you had pre-measured distances on the floor, say every 5 meters. Then you keep that camera still, you slide that light away to its 5, 10, 15, 20 meters, and those lines, elevation lines you drew, will get closer and closer together. They will not appear at an evenly spaced every 10 degrees or whatever. They won't, because this is the whole point with trying to get people to draw angles to Polaris over a flat surface. The problem they come up with is exactly what you came up with, although you come up with that diagram and we've talked about it. Mitchell from Australia basically came up with the same diagram when challenged, and I challenged him for some cash. I'd pay some cash. He came up with that diagram and demanded the money when he'd not been able to draw the diagram so that the angles didn't require a dropping Polaris. I know that you said it's due to how far you can see or this dome thing. So obviously I'm disagreeing with you, but there's your explanation. He was just he didn't come up with an explanation, however, or whatever I think of that explanation. He basically just said, no, that's it. So he didn't meet the challenge.
Yeah.
I've got a couple more super chats. Mr. E-Man, $5 Australian, says, moons, this is a good point, moons pass through the shadow of Jupiter, and the moons of Jupiter cast shadows on Jupiter. Both of those are correct. Now, I'm presuming, unless you've got a pretty good telescope, you're not going to see the moon's shadows on Jupiter. But the other way, yes, the moons will disappear from view as they pass into Jupiter's shadow, either in effect to the left or right of Jupiter, depending where Jupiter is. So can you explain how can just a light source cast a shadow on just another smaller light source?
Internal reflections, like I said. If it's getting
internal
to
to
angle,
what?
it's not going to be sorry?
Internal to what? If I've got a spotlight and I'm shining it towards you, and a cigarette lighter, but you can see it both as I'm passing it around, before the cigarette lighter actually disappears behind the spot, it suddenly appears to switch off because it's in the shadow of a light. That doesn't work.
Remember, with light you have refraction, you have incident angles.
Not in space you don't, because you've got you don't in space.
In your space it's a vacuum.
Yeah, space is a vacuum, so you're not going to get reflection and refraction.
Only to your globe it's a vacuum.
I'm sorry, repeat that.
Only to your globe it's a vacuum. Space is not a vacuum. It violates the second law of thermodynamics.
Does
Flat
it?
Earthers don't say it's a vacuum.
I do want to come back to that.
It's fake. Why do you think we say space is fake?
Because that's something that Nathan Oakley came up with. Because he can't explain atmospheric pressure gradient without gravity.
No, gravity doesn't exist. It's not a force. It can't do anything. But anyway, that will be another. Yeah,
that could be another thing. But yeah, I know because I sent the Mage weather balloon up to 38 3/4 kilometres, and the atmospheric pressure was down to 0.3%. That's a pretty damn good vacuum. It's not zero. It's not 10 to the negative 17 torr, but it's pretty damn low. And yet the atmosphere down here that we're breathing at 760 torr decides not to clear off up there.
Yeah, because we live in a dynamic system. We've got weather cycles, patterns, things. More to hit down here than it is to hit there. Remember, the gases that's moving here still has to get up there. So if they haven't got up there, you got less things hitting there too, and much less.
But why isn't it going up?
Sorry?
Even if you went on a because I don't know your background or beliefs, so I'm not going to assume anything. But from an Earth of billions of years old to a young Earth creationist view of 6,000 years old ish, whatever your time span is, why hasn't in that time all the atmosphere cleared off and evened up?
Because we live in a dynamic system.
What do you mean
We have
dynamic
cycles.
system?
We have cycles. Let's put it this way: you've probably left your car in the sun before, and
Yeah.
you felt how hot it is in the sun. If you've taken a balloon and stuck it in there, let's say a balloon that was blown up to about its maximum and left it in the car, and it got very hot, that balloon will eventually pop. But
Okay.
now, because the air is heating up, it's expanding. Now, if you had to cool it down, that balloon is just going to shrink because the gas is now moving. It's not moving as fast anymore. It doesn't have as much kinetic energy. It's exactly, we have cycles on Earth, and the lower to the ground, it's got more to hit. So that's why you got more pressure. It's hitting the ground, it's hitting rocks, it's hitting
Sorry,
trees, it's hitting
what's making high pressure?
movement of the gas.
Yeah, but why doesn't the gas move upwards?
It is moving upwards. It's just
So
got more to hit down. So more collisions. Remember, there's more collisions, and every time it has a collision, it's changing direction. The higher it goes up, you got less to hit. You got a wider area to fill.
But the whole
and the temperature is changing, and the temperature's changing up there, so it's moving slower as well. And that's why you have pressure gradients.
right, a couple of things. The argument is that you can't have space because if it was a vacuum, all the atmosphere would try and equalise it, would expand into it, wouldn't it?
Exactly, it's adjacent.
Yeah? So why isn't it? If that's saying so, you can't have 10 to the negative 17 or virtually zero because vacuum, would suck, blow. All the atmosphere would clear off into the vacuum. Okay.
No,
Yeah, but sorry, if you can't have that because that's what's the word? It's breaking the natural laws, or however you want to put it. Then why is it okay to have it against 0.3? That's 99.7% vacuum.
The difference is a vacuum doesn't suck.
No, I know it doesn't.
Higher pressure forces itself into the lower pressure.
So why isn't Sorry, go on, carry on.
Now, if you've got a large area, remember, it's still the same system. It's a closed dynamic system. You've got the gases having to compete with area change, pressure change, temperature change. They're all inversely proportional to one another. If the pressure changes, the temperature changes. The temperature changes, the pressure changes. The area changes, they change as well. And because we live in one closed dynamic system with such a large volume, it changes respect to how the temperature there, how the area is, how the pressure is, and everything. So remember, those things are really related to each other.
Well,
and that's why you have pressure gradients.
Right. Well, I measured both temperature and.
Burj Khalifa.
Sorry.
On your Burj Khalifa thing, I think you went on the Burj.
No, yeah, I did do it on the Burj Khalifa as well.
Making my point, yeah.
Yeah, that was measuring atmospheric pressure, and just as an aside, although I didn't measure the temperature apparently outside is about 5 or 6 degrees lower at the top than it is at ground level. No, I was meaning on my MAGE probe. We measure the pressure as you go up. It drops in a curve. Okay, a nice curve. So for every so many meters, it doesn't drop the same. It drops exponentially less and less and less. So the curve becomes shallow. The temperature doesn't. The temperature was dropping for a while. Then you get towards the stratosphere. The temperature rises again for a while. Then it drops again. And that happens a couple of times. That the direction of the value of temperature changes. It gets colder, it gets warmer, it gets colder, it gets warmer again.
Why would the temperature change there?
Well, I'd be interested for your explanation, because the point was that the pressure was never going up, and yet the temperature was going down, going up, going down.
Okay, let's put it this way. If you only have 5 moles of something and you put it in a volume of a tin can, it's going to have a higher pressure than putting those same amount of gas in a bucket, for instance, a 10-liter bucket. you're going to have a difference in pressure, correct? But it's the
Yes.
same amount of gas.
Yes.
Now, when you're that high up, you've only got a certain amount of gas that's reached there because of all the variables I've just stated. So it can heat up, it's going to move faster, but if you've only got that amount of moles to move, you can only have that amount of pressure.
The point is there was no correlation to the between the pressure, the atmospheric pressure at a given height and the temperature. You know, it's not like the pressure that every time the pressure dropped 10%, the temperature dropped 10%. It might have done for a while, but then the temperature started going up, even though the pressure continued to go down at following the same beautiful curve.
It's inversely proportional. Remember, the higher you go up, the more volume there is for it to hit. So that already drops the pressure. The temperature can increase, but it's still going to change because the volume is different. You understand? So the wider the volume, the lower the pressure.
Yes.
It changes now with the temperature change. That's what I'm saying. On your globe model, what changed the temperature between that band? Because your sun is millions of miles away.
Yes.
What's heating it just at that band?
What's heating it just at that band? Well, it's. Yeah. I mean the. Excuse me. We get the radiation from the sun striking the Earth and some of the air molecules, but a lot of that infrared or a lot of that radiation is then reflected back up. That's why it's comparatively warm at ground level. I don't know. I'll be honest and say I don't know all the ins and outs, but you can have a look at graphs. You can just do a Google for images graph of atmospheric pressure versus temperature. So you'll see the various, you've got the various layers, the stratosphere and so on, and you can see as you go through those layers, the temperature drops, goes up a bit, drops again, goes up, maybe for a long while, maybe it hangs around a bit, but then it drops again, and so on. So it's not to do with height, it's not to do with the pressure. It's
remember, it's inversely proportional. If you know gas
but
behavior,
it's not inversely. But we're talking about atmospheric pressure. We're not talking about all the stuff with gas laws and ideal gases in containers.
But atmosphere is gas. That's the problem we have. Atmosphere is gas. Just because you call it atmosphere doesn't make it not gas anymore.
Okay, so you're at given height X, and the temperature is -10 at that height. So I know what you're saying. You've only got a certain amount of gas molecules to hit you to transfer heat. That's true. But then you go up a further distance, a further altitude, and it's now dropped to -15, and the pressure has dropped a bit more. So you think, oh, cool, that could be related. But you go up further still, and there is less pressure. Suddenly the temperature's gone back up to -10. So that means your independent variable of height does not affect directly proportionally. No, but I'm talking about the altitude you've gone up to. Therefore, the pressure the independent variable of the pressure you're experiencing, because that pressure is going down at a predicted rate, but the temperature doesn't. It does not equate directly to that.
Temperature, pressure, and area, volume is always linked together.
It is with your gas laws, but we're talking about the atmosphere and atmospheric pressure here.
Atmosphere is still gas.
Yes, of course it is. But if you
then doesn't it have to be then still apply gas law behavior to it?
But you've got all the stuff. If you've got a container with a fixed volume of gas, if you squeeze that container, then the pressure will go up, obviously. Yeah,
changing the volume.
Exactly. If it was like a piston thing and you dragged it out, the pressure goes down. Yeah, and that's exactly predictable. And
the temperature changes.
Yes, but that's not the same with atmosphere. We're always telling you guys there's a difference between gas pressure and atmospheric pressure. That's an example of it.
What's the difference?
Well,
what's the difference?
Well, I've shown you. For instance, you know that if you change the volume of that gas but keep the same amount of gas, but change the volume, either expand it or drop it, you'll get a predicted pressure change and temperature change. Yeah, but but what I'm saying, and that will hold true. You expand it the same amount, you're going to get the same change in pressure or temperature. But what I'm saying is, with the atmosphere, yes, we've got an exact pressure change. We can predict the temperature. The pressure. We know that it drops down at a curve. The top of Everest is approximately 32% of the pressure down at sea level. Approximately. It might vary a bit day to day, but that's roughly it. So you know that if you go up to the top of Everest, you're going to have about 32% of atmospheric sea level pressure. But you go up higher still, the pressure continues dropping, beg your pardon, continues dropping following that predicted curve. The temperature doesn't. It's not as closely tied as it is with your experiment with a container with gas expanding or contracting the container.
If you take a barometer, are you using a container to measure that pressure?
Barometers, well, the old-fashioned ones actually, yes, they had in effect had a little container with that got compressed, didn't it? I'm not sure totally of the internal workings.
Yeah, today it just works with a surface wall that picks up the electromagnetic, that pushes the pressure on it.
Yeah, not electromagnetic. Yeah,
sensor. You're having a sensor.
Yes.
Today you just have a sensor. It's literally a surface, so it's still a container. It's just an open container because it's having a surface to hit against.
Flatzoid. I'm amazed. You said something that I'm not being rude. You said something I agreed with. We had all this stuff. Oh, you can't have air pressure without a container. You can have air pressure against a container or any flat surface, or any surface rather. You've got it.
Surface is a container. It's a wall, a container.
A wall. Yeah, absolutely. So that's why we can have pressure without a Nathan Oakley container.
But your Earth is said to be an open system adjacent to a separate system, the vacuum of space. That means that the gas we breathe, atmosphere is still gas,
yes,
would evacuate and it would fill the available space. Remember, gas can only change direction with collisions. So it's literally
no. Yeah, I can pour gas. I can pour carbon dioxide. It will pool on the floor. Mustard gas.
Disperses.
Sorry, say again.
It still disperses. Just takes longer.
Yes, it will take. Well, yeah, because those individual molecules are moving, but a heavier gas like xenon. You fill a balloon with xenon, it will just drop to the floor. So if you could pour, okay, you're not going to see it, but you could pour xenon, it will fall to the floor. We know that. We've seen the tests with a fish tank full of is it sodium hexafluoride or whatever it is. It's a heavier gas. It's a gas that has a greater density. So gravity has a stronger pull on it, so it tends to go down. But it can't. It's not as heavy as water, so it's not going to stay there for days before it evaporates. Relatively quickly, perhaps over a few minutes or hours, that gas will disperse. But
that's the problem.
Sorry, problem with what?
That's the problem we have. That fish tank, if they have to leave it open, it disperses. Gravity is not pulling it down. It's still escaping the fish tank, just like it would escape Earth into the surrounding system.
Well,
just because denser takes longer because it takes more energy to move a denser object.
Why? It takes more energy because that denser object has a greater. Each molecule has a greater mass that's being pulled harder by gravity. So if for instance, in that fish tank of sodium hexafluoride or whatever it was, if you had a can full of helium or even oxygen, if you opened it under the surface of that tank of heavy gas, that helium or probably most other gases would come straight up and out. They're gas. Why did they come up and out first?
Okay, I've got to think that, but I just want to quickly, I got a super chat. Face Reality, $2. Ated Iokora. Can you show a vacuum without container? That was to someone else. But yeah, back to our thanks for the super chat, Face Reality. Back to our thing with the fish tank.
I've got a couple. I've got a couple of super chats as well, if I may.
Oh, you
Yeah,
okay.
Ted Lacoca says he's no model to show everyone. Doesn't see the sun. I think that's going back to when we were talking about you modelling everything. Extra J super chat $5 say towards you. Does perspective make an object? Does perspective make objects appear where they are not? If yes, perspective bends light. If no, then your BP tower, I'm not sure what that is, BP tower and Polaris explanation doesn't work. I think it's going back to your diagram, which, I did try and explain the thoughts to you, but I think we got lost. So looking at the star at 40 degrees, but you're saying it hasn't physically got any nearer. So if it hasn't physically got nearer, the light must be bending.
Light is not actually bending the perspective. It's literally the angle. Just like I showed with that light going down to the distance. It's not physically dropping. It's not, the light's not bending. It's just the angle is becoming more acute. That's it.
I think I'm going to, because I have got a way to, that I've been thinking on and off a couple of times, that I might try and do a video just to address this. And it's not to have a go at you, but it's to explain, well, to discuss this anyway. So I'll come back. I will have a look at that. And Ted Lacoca super chat again, $1.99. Oh, sorry, that last one was from Extra J. Beg your pardon. This one's Ted Lacoca. It says, it's your paint can talking about. If it's to scale, how tall would that paint can be if that was on Earth? So your paint can's to scale of what?
I didn't take that into scale, so I wouldn't know. But I'll do that other one where you say I'll take the 5 meters.
Yes,
differences.
yeah, do it. So in effect, if you take your start position, draw a line on the floor. I don't know how long the room is, but let's say for the sake of argument, 5, 10, 15 meters. Keep your camera in one position. Take the light so we can see the angle of elevation above that floor at 5 meters, 10 meters, 15 meters, 20 meters. It'd be good if we could have several distances. It doesn't matter if it's 5s, it could be every 2, whatever. And I predict that your dotted lines that you drew across the screen, the top 2 will be further apart than the next 2, further apart than the next 2, further apart than the next 2. It looks like I've got 2 more. I'll get through. Sorry, mate, you've got some as well.
No, you're saying Iacocca pronunciation.
Yes, yeah, Iacocca. Yes, and I remember we've had that before. I'm sure that Ted, I seem to remember that on a stream before. So sorry about that, Ted. But why can't they do L's and I's that look very different? I don't know. But my apologies, Ted Iacocca. And he'd also super chatted saying, Flat, can you show pressure gradient in a container?
Yes, I can. I've got it on a video I did recently where we have a guy taking, I think it was Zen Garcia. Oh no, who was it? Was the guy, one guy on Globus? Anyway, he took a container and he put it in an ice bucket and he put a pressure valve down at the bottom and he measured difference in the bottom to the top when he used the heat gun on the top in a closed container just by changing the temperatures.
Right, so yeah, okay.
So
do you know, that's sort of sounding familiar. I think I may have watched that video of yours. That was some time ago.
I had one recently where it says gas, and it says what? Okay. It was based on a debate with Aussie Jesus and Reed.
Okay, well, I've spoken to Ross, who's now known as Iron Horse, isn't he?
Iron Horse, yeah. He used to be Aussie Jesus.
That's Iron right, that's right. And who's the other guy? Reed? I don't think I've heard of them.
Yeah.
I don't think I've heard of this.
Mark Reed, I think his name's Mark Reed or whatever.
Okay. Greg Cott super chatted $2.99 Australian saying orthographic view takes perspective into account.
Is that so? Can you show me convergence in orthographic view, please?
You just did with your diagram.
No.
Yeah, but your diagram.
Yeah, but I was trying to show perspective. I'm not saying it is showing perspective. I was trying to. You understand? Because orthographic doesn't take perspective into account. Orthographic is simply just the angles, literally just the angles. It doesn't take anything else into account. With perspective, you got things like refraction, you got conversions, you got convergence, you got compression. How are you going to put all that into orthographic? Yeah, it's a bit difficult.
Well, no, I'm not. It's because you're trying to come up with an explanation. You come up with things like compression. If you had an orthographic, if you've got three people, okay, each 1.8 meters tall, okay, and you stand them 100 meters apart from each other, orthographically, you've got the three little diagrams: a 1.8 meter, 1.8 meter, 1.8 meter person. So there's 100 meters between each of them. From the point of view of one of them, if you drew eye lines showing their head to their head and their feet, that's the angular size they'd appear. Then you look at the further one, that angle it appears smaller. Yeah, because that's angular. Perspective.
No, that's not. That's only angular. It's not showing.
Yeah, but that's what it is.
Convergence. Remember, on perspective, the ground seems to be ramping up to the convergence zone. You don't see that. You don't see the compression of the objects actually compressing into the distance. You don't see refraction into distance. When you look into with your eyes, you see 3 dimensions. You look into a 3-dimensional world. Orthographic only deals with 2 dimensions.
Well, actually, with your eyes, you get a 2-dimensional image in your eyes,
yeah,
and it's upside down. You turn it into a 3D view with your stereoscopic vision.
No, we live in a 3-dimensional world.
Yes, we do live in a 3-dimensional world.
It's just translating it to 2 dimensions to your retina. That's all.
Well, it's more than
It's like a photograph. The sense is picking a 3-dimensional image and flattening it. That's all it's doing.
Yes. The light passes through the lens onto your retina, and it's projected, like with a camera onto a CCD, it's projected onto your retina. Yeah. So you have a 2-dimensional picture from your left eye, a 2-dimensional picture from your right eye, both of which are upside down in the eye, and your brain, in effect, turns them the right way up, overlays the 2 images, giving you the various parallaxes, which provides you with a 3D view, if you like, of it. And I've had...
Yeah, I've got a super chat.
Okay, you go on, you go first.
A £5 super chat. Tell me, Craig, how the hell does orthographic view take perspective into account? It don't.
Craig? I'm fighting the flat earth now. Oh, man.
Greg, yeah, he said Greg. I don't know.
Greg. Yes, it was Greg Cox. Beg your pardon, yeah. Well, I've just got a couple of super chats. A freebie super chat for members for Now Opinion, a member for 31 fine months, saying you get a 2.5D view with your eyes, I guess. And a super chat from Mr. Turing Test 2. Good evening, Turing. Saying, I'm late to the stream, but I see you've been at this for over 2 hours. Kudos, Mr. S. Kudos.
But we're having a nice conversation, though. That's all I like about it. It's not...
Yeah, well, no, we are. We're disagreeing. And to be honest, I'd much rather this, because I do enjoy the discussion and the argument. Because assuming that neither of us is just outright lying, in effect trolling, okay, assuming that's the case, then we've got different views. And I think it's good to explore those views. And if you are correct about something and I am wrong about something, and you're able to explain something to me and I understand and think, do you know what, he's right about that, then I've learnt something. That's a good thing. On the other hand, if it's the other way round, maybe I can show you something and you think, do you know what, I hadn't thought of that, and that might affect how you hold your views, and that's good as well. I mean, that would be ideal. I'm sure we could sit here and argue and shout at each other or take the mickey, and it can be fun, let's be honest. But, I'd much rather argue these things out and argue these things out. And Judy Bassett, member for 23 months, thanks, Judy, says, thanks for the fun, Mr. Sensible, which is just what I was going to say. I think this is fun.
Yeah, it's fun. We should definitely do it again.
Yeah, I think so. I see someone's been timed out on my stream for a while. I don't know what they've been up to. I do welcome people with all views on the channel, as long as they obey standard sort of rules for chats. I would ask mods to be very careful that as long as someone is not being, terribly insulting or carrying out hate speech. It's one thing to call someone an idiot, but I think we all know that some things are way beyond that. As long as they're not doing that, then I don't have a problem with it. And I'm quite happy to have flat earth views on here as well, because you can all rip into the argument. That's not a problem. But please be careful about timing people out.
Faciality $2 super chat. What we all have in common is never going to space. Because remember, I think you had a opportunity the last time or something, and you just didn't make it or something like that.
Well, there was the I've forgotten the guy's name. That Japanese guy doing his moon thing. I applied, but let's be honest, that was a bit of a long shot, because no doubt millions of people applied. And they have eventually. It was really slack, really. They didn't contact anyone. People were saying, "What's happening? What's happening?" They have picked their group of people, and that's fine. So I didn't really hold out any hope. It was fun to apply, and you never know. Wow, what a scary thing to do. But I think it's one of those things. If I actually had the opportunity, if he'd said, "Right, okay, you're on, you can go for it," and I'm thinking, bloody hell, that I'm going to be sitting on top of a rocket with, okay, they may be a lot safer than they used to be, but they're still damn dangerous things. Would I do it? I'd have to say yes. I'd have to say yes. Would you do it? Sorry, Zoid, would you do it?
If I believed it to be real, probably.
Well, but on the other hand, if you don't...
If I see it the way I see it, I don't think anybody's going up in a rocket there.
What do you mean? Do you mean if they said, "Hey"?
I am busy with the video. I am busy with the video explaining why. So I'm not going to give it away.
No, okay, I respect that. You don't want to give, but let's see if this is something you can talk about without spoiling your video. So if they said, "Hey Zoid, your name's been picked. You can take part in this trip. You'll go up in a rocket, orbit the Earth a couple of times, go round a loop past the moon, and come back, orbit, and then splash land."
I'll do it, but I'll be very skeptic though.
Do you mean you okay, so you agree to do it, and they say, "There you go, sit you in the rocket." Are you saying you think that what you actually see and experience would be faked? Is that the sort of side you're coming from?
Sort of, yeah.
Okay.
You'll see what I mean with my video. Why?
Okay, no, that's fair enough. I do respect that. I've been in a position where I've had someone try to ask me about something I was doing a video on, and you don't want to let the cat out of the bag. I understand that. I do.
Skeptic 936 $5 super chat. Is Godzilla in the house? Yeah, he's been in the house the whole time. I don't know where he is now. Maybe he's just listening in the background. It's good to see all the super chats tonight.
It is. And Ted Iacocca, I'll forget for next time, Ted. For another time. Sorry, mate. $1.99 chat says, should the North Pole winter have a more equalised atmosphere?
I wouldn't say so. I mean, look how wide open the North Pole is there. The area is much wider open, and it's colder, so it's going to give a difference.
But the difference...
Remember, on your ground level, you don't really see much of a difference, but it's probably because of the size of the container.
You don't see much of a difference. I mean, I'm not sure. Maybe a very low pressure is whatever it is, 980 bar, and a very high one is 1020, whatever it is. It's something of that order. And yet here, in the winter, we could have -10, -15 maybe at a push. And yet, was it last summer, we had 40 degrees plus. But the air pressure doesn't change that much.
Yeah.
So
I mean, we realize the bigger the system, the less change there is.
Well, I mean, if you feel that I mean, we have, to be fair, covered it pretty much. I think to round off my point is this whole argument of if space can't be a vacuum, otherwise the atmosphere would go into it. We've all seen that experiment with a guy with a double-ended glass thing with bromine in one end and vacuum in the other. Opens the tap, boom, it equalises. Of course, none of us would deny that, because you've got vacuum right next to a bromine at a pressure, let's assume it's at atmospheric pressure of about 14 psi, 15 psi. So, yeah, it's going to go up. But if the difference between those is 38 kilometres, why doesn't it just bang up there? Why does it decide, do you know what, I'm going to hang around here a bit and blow around? I'll spin around a hurricane a bit. But it's true. Why shouldn't it? Why can't it? Sorry.
Remember, it's in the same system. The thing with the entropy, you require two separate systems. So as soon as you have the adjacent system not having a physical boundary, that's when entropy will increase and it will fill the available space. We live in like I said, we live in a dynamic system, and because it's such a great big area system to conform, it's got cycles and everything inside. It's dynamic. It has more variables to contend with before it gets up there. Now, that's why with your Burj Khalifa thing as well, it's perfect.
Okay.
Because you went up in the elevator and stuff, and the pressure was decreasing the higher you went up.
Yeah.
Because you are in a huge system going up. There's less of the gas higher up there. It hasn't reached it yet.
Sorry, when you say a system, are you talking about the elevator, the building, or the Earth as a whole? Okay, yeah.
Remember, in the elevator, you already got that amount of mold still hitting around everywhere. They're still hitting around.
Yeah, but of course the elevator,
the
elevator isn't airtight. Thank goodness, otherwise we would tend to die. But so as you're going up, I mean, air molecules are moving around, and if there's a cracks around the door, some are coming out, some are going in. But as you're going up, there's more going out than coming in, and it's equalising with the pressure in the shaft.
It's just got to do with Boyle's law. I mean, you can take an aeroplane, for instance, and you can take a bottle, an empty bottle, and you can just put the lid on there.
Yes. And
you change in altitude. You're still in the compressorized airplane, and it still shrinks or it expands because of the different variables.
Well, yeah, aircraft are pressurized, but not to the same pressure there is at ground level. Otherwise, if it was pressurized at ground level and didn't drop at all, your ears wouldn't pop, and we know that they do.
Yeah.
But they do maintain a minimum pressure, because otherwise you would tend to die at 35,000 feet or whatever it is, because there's not enough oxygen. So yeah, they're compressed. But I know you're saying, if you had that bottle that you closed while you sat on the tarmac, then when you're up at full altitude, the air pressure has dropped to that cabin pressure level, so that container you're holding, whether it's a balloon or a plastic bottle, will have expanded or be trying to expand, of course, to equalise the pressure. And if that pressure difference was enough, when you open it, it won't just open it, go, psh, won't it?
Exactly.
Which incidentally is everything. When we're talking about this whole thing about atmospheric pressure, and some people, I don't know if you ever have, but some people said, oh, well, why do you need a tyre around a wheel? It's to hold the pressure in. And what I was thinking is, if you stuck a knife in the side of a tyre, pull it out, straight away you get, psh, don't you? As the air rushes out, it's trying to equalise. But it doesn't continue to rush out at the same speed. What you get is a...
Okay. Yeah, remember...
Because the closer the bigger the differential, the greater the force of that pressure pushing out.
It's the same as you've looked at like Black Friday, where the people go crazy, especially in America, where they open the doors, everybody's standing there waiting, they open the doors, everybody's pushing through the doors.
Yeah.
The first amount of people pushing there, they're pushing much more against. But as soon as most of them got through, the people at the back have more space to travel through. That's the same with the pressure with the...
That's quite an interesting idea. So you're at the front of the queue, Flatzoid, okay? The doors haven't opened. Everyone's sort of pushing forward. Okay? You've got 100 people behind you all pushing forward. You're going to be pretty squashed. And I mean, we know that people die in that sort of, crowd stampedes and that. Absolutely. Yeah. The person behind you has got 98 people pushing on him. You had 99. Halfway back, the person there has only got 50 people pushing on him. You got the full 100 Okay, so yeah, it's going to hurt, but perhaps is no way it will kill them. It will just hurt. And you get to right near the back, and there's only 2 or 3 people behind shoving. That's a pressure gradient. That's exactly the same. Turn that upright. Yeah. That's how we have the pressure gradient.
Remember,
the molecules, or the flatzoids, right next to the door, the molecules nearest the surface of the Earth, have the weight, have the pressure of all those other people, all those other molecules, all pushing down. That's what gives us an atmospheric pressure gradient. That's why there is no container. You're not having to be contained. Sorry, I'll just finish off. You don't have to be contained to feel that pressure. You've got that pressure just because it's all those people behind you shoving forward to get into the Black Friday sale. Same with the air. It's only got, the only pressure it's got is the weight of all the molecules above pushing down. Sorry, go ahead.
What I was trying to do with that was explaining Avogadro's law and stuff. Remember, the more people in a certain space, the smaller the area. So the volume. Remember, we said if you close the volume, you're going to have more pressure. So once those people have left, there's less people in the same amount of area. So there's more volume. The volume has increased compared to the moles. That's why there's less pressure.
Yeah, there's less pressure. There's less density of your gas or whatever in there. Because the volume hasn't increased. If it's a cubic meter with X amount of gas, well, you pump more gas in, the pressure will increase because the volume isn't. If you open the valve, gas starts coming out, the pressure drops, and then perhaps you stick on a vacuum pump and suck most of it out. Then you've got a very low pressure, but the volume is still the same. The area is still the same.
Yeah, but you got less amount there.
You got less gas in there, yes.
Amount, so it's got more space to move.
Yes.
So therefore the pressure is less.
Yes.
Because you got less collisions.
Yes.
Every second. Do you understand? That's the reason.
Yes.
Okay.
Yeah.
But now that's what I was trying to explain. But obviously people aren't gas, and I mean you literally need physical containment to have pressure, because that's what pressure is. Pressure is the physical force exerted on a surface area, on a physical wall.
Oh, hold on. On the walls of a container or any other surface. You said it yourself, which is why I was so pleased earlier on. You said about your pressure your barometer, whatever, with a sensor. It's the atmosphere or the gas pressing on that sensor, a flat surface. Yeah. Now that flat surface might be in a room, it might be outside, but you're getting a pressure on that surface. Yeah,
exactly. So
you don't need a container.
You do. You need to have the pressure. To have pressure, you need the container. Remember, a gas molecule can only change direction with a collision.
Yeah, only. And it's hit my hand.
So if it hits my hand and it goes up into the sky, it needs to hit something else to come back. And usually it hits another gas molecule because it's more compacted at the lower ground. Some of them are going through because they're just missing, and that's what keeps going and going on, and that's what still hits higher up. You understand?
If my hand is the pressure sensor, or I'm holding it, or it's mounted on my hand or whatever, I am basically reading the amount of collisions against it, aren't I?
Exactly. So that's pressure. That's
pressure. That's pressure. It's just my hand.
So
there's no container here. Now that molecule that hits me, is going to bounce off. Now either it's going to continue on forever, or it's going to hit something else, whatever that is. Could be the walls of a container, could be an object, could be another gas molecule, or it could be, if my hand was like that, it's gone up, and with gravitational pull, it's come back down again.
But gravity doesn't do anything on the direction of gas. That's what I'm saying.
But it does. We've already talked about that. Xenon, sodium hexafluoride. How could I pour it? If I've got a container of that heavy gas, and I open it, and I, tip it. Well, first of all, why doesn't it just rush straight out? But if I tip it out to exit my jar of gas, why doesn't it just disperse equally? Why does that xenon or heavy gas go down?
Because it's denser and it takes more energy to disperse. That's why. Remember, less dense will have to go up.
So
denser
why?
Go down. But that's why I was trying to get with the fish tank thing. If you had to leave that fish tank open, it will disperse out. If your gravity is pulling down, it would stay in there indefinitely.
No.
Yes, it would, because
it would have a tendency to. But remember, with temperature, for instance, those molecules are moving faster, or if they get hit if they get hit by fast molecules, that is by definition means a higher temperature. They knocked. It's almost like snooker balls. But I was saying about that container, and if I tipped it upside down, the heavy gas, xenon or sodium hexafluoride or whatever, goes down. You said because it is denser. Why? A gas is not a single object. It's lots of molecules. Now that molecule of sodium hexafluoride is heavier. It has more mass than oxygen, nitrogen, carbon dioxide and the other gases. Therefore, if they're both wanting to go down, only one can be in that space. That will be the heaviest. It gets pulled down faster and it gets pulled down harder by gravity than a lighter molecule.
So then why doesn't sulfur hexafluoride always just stay in the bottom of the fish tank?
Because if you were putting metal ball bearings, they would metal ball bearings would stay in there, wouldn't they? Of course, they're heavy enough and dense enough that unless you were shaking the thing around, then perhaps some might slop out, but they would basically sit there. But the difference in mass between the sodium hexafluoride and other gases, it's heavier, but it's not that much heavier. So it doesn't take much to disturb it and get it. I mean, you've got air movement anyway, which can bombard and knock molecules away. Just like with the atmosphere of Earth. If you took the entire Earth to be our fish tank, we filled it with atmosphere. Now, my claim is that the reason the atmosphere stays there is because of gravity. And you'll say, well, why doesn't it clear off into space? Some of it does. I forget exactly, but we lose about 70. I think 70. Yeah, exactly, 70 to 80 tons a day.
To the globe model, but like I'm saying, if gravity is pulling something down, and it loses its kinetic energy, so let's say sulfur hexafluoride is now so dense, it's at the closest that it is to the center of mass, which is the Earth. It should be staying where it is. It's not staying where it is. It's still dispersing, and it's going into the surrounding system. Therefore, it would be overcoming your gravity.
But the thing is, if you get different gases, like say carbon dioxide, sodium hexafluoride, xenon is another one I know, but different gases have different densities. So you could have a separate fish tank for each of those gases, and at the same time fill those fish tanks with carbon dioxide, sodium hexafluoride, xenon, and so on. They will all disperse, but I can predict that the one with the lightest gas will disperse first and fastest, down to the heaviest gas will take longest to disperse. So they will disperse, but because they're heavier than the general atmosphere, only a bit. Only a bit.
But let's put it this way. Let's take, like, you guys love to use the bouncy balls as a equivalent.
It's a very good analogy that Nathan Oakley hates because he doesn't understand it, but go ahead.
Yeah, now you've taken that bouncing ball and you've dropped it into a fish tank. Now it's lost its kinetic energy. Now it's static at the bottom of that fish tank.
What, have you discovered absolute zero?
Because you guys say it's gravity pulling it down. Now the gas that's so dense, it's supposed to be now staying static.
But gas never stays static, it moves because it has temperature.
Exactly, so gravity doesn't do anything to it. That's why it does not have any direction on the travel of gas. This is physics 101.
It does have an effect, but the less dense a gas is, the less effect that gravity can have on it, which means it's a lot harder for it to hold on to hydrogen or helium to the extent that it rushes up to the upper reaches of our atmosphere, and we lose a lot of it. Whereas heavier gases, they'll want to disperse as well, but because they're heavier, the gravitational attraction, the force applied to them, is that bit more. They're constantly moving. That tank of sodium hexafluoride, if you could look at the individual molecules, they'd be churning and flying around everywhere. But only some of them will achieve enough velocity to escape from that tank. Give it enough time, depending on the gas, it might be minutes, hours, or days, or whatever it is, but given enough time, that gas will disperse. But I bet actually if you had a really heavy gas and then went back with some sort of detector a few days later, there will still be some molecules of that gas in there because they haven't managed to escape.
Okay, then let's put it this way. Like your mage with the balloon.
Yeah.
Just before it popped, did it have a higher pressure than the outside or a lower pressure?
The pressure... hold on, I'm trying to think which way around.
Inside the balloon.
Yeah, because it was filled at ground level, not filled all the way up, otherwise it'd be popping way too soon.
Yeah.
But you put in enough to lift it. Sorry, this is me trying to think it through as I'm sort of... Okay, as you go up, we know that the atmospheric pressure is dropping. The amount of gas inside that balloon stays the same. So it's able to stretch the balloon to a larger size. We saw that the balloon grew. So if the pressure outside has dropped, let's say from 14.7 to 10 psi, it will try and equalise. So the 14.7 gas, if you had it at 14.7, would try and expand until that volume equals 10, the same as the outside. It won't be exactly the same. It will be slightly higher because you've got the stretchiness of the balloon. But it will.
So as the whole, it would be heavier, correct? So gravity would be pulling the balloon downwards over all the loose molecules of gas that's not really there around it. Why is it still going up?
Yeah. Sorry. Do you know? I think I know what you're getting at. Just say that again, Flatzoid, because
because the balloon would be heavier.
You got the weight of the latex.
It's like a container. Yeah, it's like a container with gas inside it. So it'd be, according to gravity, it'd be heavier than the vacuum around it, the low pressure.
I'm going to have
gravity
to.
is stronger, pulling the balloon down and not letting it go up.
Well, gravity is always pulling the balloon. The question is the volume of that balloon? It must. Yeah. I tell you what. To be fair, I'm going to have to look into this more. As I said, I was trying to sort of talk it through to think it, because obviously for it to work, the force upwards has to be greater than the gravitational pull downwards. So you've got the weight of the equipment, which is the cameras, the batteries and all that stuff. You've got the physical weight of the string, etc., the physical weight of the latex balloon, and then you've got the gas. That's the only up force, if you like. And the reason it's an up force is that volume has to have a lower density than the surrounding atmosphere.
But it's going up.
Yeah, it's going up, and of course, and that's forcing a balloon to expand until it reaches a point where the latex cannot stretch anymore, and so the balloon bursts, releases the gas, everything comes down.
But that's my point. That's why I say gravity cannot overcome entropy, because the gas is literally pulling heavier objects up away from where gravity is supposed to be pulling it down.
Yes, but the volume,
gravity.
The volume of the atmosphere displaced by the balloon and the equipment must weigh more than the weight of the balloon and the equipment. I'd have to think this one through. I mean, it's actually a really interesting point, but because it's twisting my mind a bit, because I didn't measure, and I've not looked into what the pressure is inside the balloon. It must be. Do you know, Zoid? I will look into it. That's actually a really interesting question. Okay, I've just had a super chat, another one from Ted Iacocca, 199. Thank you. It says, "Why do gases fall anyway?" Flatzoid.
They don't. They move in all directions. They don't. They move in all. Remember that.
But we just showed it, or in our thought experiment, we just showed it. I opened a jar. I tip it on the side, open a jar of sodium hexafluoride, it falls down into that fish tank. Whether it disperses...
Remember, it's denser, and you turn the cup upside down. It's hitting from the cup and then flowing downwards, correct? If you lift that cup right up, it's still going to disperse. It's not going down. It's going to go upwards out of the cup. It's not falling. It's just moving in all directions. Density is just simply, he's got another super.
Yes, he has a follow-up. What is density then from Ted? Thank you.
It's the amount of substance in a given volume.
Yes, it is.
That's it.
So why is density a direction. I saw someone somewhere posted, if I had a seesaw and I put a bag of sugar on one end and 2 bags of sugar on the other end, they're the same density. Why do the 2 bags go down and not the 1 bag?
You put more substance on the one side of the scale.
So it's not the density then?
No, it's density. Remember, you've just added more. It's like
you can't add more density. If the sugar is 1 kilogram per cubic whatever it is, I've got 1 kilogram per cubic whatever at that end, and I've got 2 kilograms, but that's twice the volume, so it's the same density.
It's as simple as this. You got a cube of a certain weight because of the density. It's got substance. The substance is what gives it the weight. You know, that force
you mean the
on
mass?
Scale. Okay.
The mass of it.
No, I'm not going to really say mass, because mass is implying you guys have a gravitational pull. So I'm not going to say mass. So let's just say it's got a weight to it, because it's the pressure measured on the scale. Because that's exactly what weight actually is. It's just a pressure measured on the scale. Now, if you've got that substance giving that weight, and you've just taken another brick with exactly the same weight, you've added to the weight. You've just put more substance on that scale. You understand? It's not.
Yeah. So what you're saying. Yeah. So what you're saying is the greater on our seesaw with 1 bag of sugar on one end and 2 on the other. The reason the 2 goes down is it's a greater weight.
That's it.
Yeah.
And it's not because of gravity. It's just because you put more of physical substance on the scale. That's it.
So what is weight?
It's the pressure measured on a scale.
Yeah, but what? Sorry, I'm not trying to trick you.
Pressure. Pressure.
Weight is mass times gravitational acceleration, which is why.
No.
Sorry, no.
According to your globe, it's gravity, but I'm telling you, it's not. It's simply the pressure.
So what's causing that pressure then on your non-gravity Earth, whatever shape it is?
The physical object is the pressure.
I'm sorry, say again.
The physical object is causing the pressure.
Yeah,
remember, denser objects have more pressure than the air around it.
Okay, but we're going round in circles a bit. You started off by saying, why do gases fall? So you said that the object, or the denser object, gives more pressure. Why downwards?
It's denser. The air around it does not have enough pressure to support it.
So if I turn that bag of sugar up the other way, would it shoot upwards?
No, because the bag of sugar is denser than the air. Remember, the air needs to have enough pressure to support. Let's take, for instance, the Magnus effect.
I've heard of it. I've heard of it, but I don't know anything about it really.
A golf ball, for instance, and you stick it on top of a blower, a leaf blower.
Oh yes, I know. So it will sort of hovering
around there.
Yeah.
That ball is supposed to fall, but the pressure from the air is pushing it up.
Yes.
The pressure is greater.
Yeah, there's a greater for. You've got. That ball, whatever weight it is, whatever mass it is, has a certain weight pulling downwards according to gravity. So there's a force downwards, but you've got a counteracting force upwards. If it's exactly equal, it will hover. If you could turn that blower up really, really high, it would shoot on up, wouldn't it?
Exactly.
Yeah.
Pressure. That's what it's pressure.
Yeah, but it's a force. So you have a force coming down. So what's the force coming down then? Density.
Yeah, exactly. The object is causing a pressure. It's pressing on the air around it. And because it's got a greater pressure, it cannot support it. So as soon as the air around it's got a greater pressure, that is why you have buoyancy.
So are you... But okay, I know that we're always asking this, and I have to ask it though, but why that way? Why downwards?
Sorry, I just got a super chat. I'll give you one now. 96 $20 US. Thank you very much. Hey, Flatzoid, have I told you I love you? What? Have I told you I love your channel recently? Thank you very much. You have. Thank you very much for your support, Skeptic, and everybody else. Yeah. I'm enjoying Mr. Sensible's channel at the moment as well. Thank you very much.
Good, good.
Okay, back to the
Yeah,
thing. But I think you
and
were
I've had
saying,
one from Dr. Nimrod
yeah.
for €2.49. Says, how much does NASA pay Flatzoid to be a massive Poe? Yeah, come on, Flatzoid, tell us how
I'm
much.
not a peacock. I'm not a peacock. Come on.
Oh man.
But yeah, because the thing is, a lot of people tell me, I don't know if you watch my streams to the end, and usually I say, "May the pressure be with you." You know why I actually give that statement?
I'll be honest and say I do dip into your streams, but I don't tend to watch the whole things because you have
Yeah,
got a lot of them and they are quite long. So I dip in. Oh, I
I
dip
have
in.
every night. Frankly, I have every night, and yeah, sometimes it goes on 3-4 hours. So.
Yeah.
Yeah, the reason I say that is because people usually tell me the pressure is not a force. But according to physics, a force is something that an interaction that can cause a push or a pull. And pressure literally can cause a push or a pull. So when you have a pressure being able to push or pull, that gives its magnitude, which makes it a force.
But with so many forces, if you're stood there and I stand in front of you and push you, we know it's a force. We can see the direction of the force is being applied. We can see that you stagger backwards. Okay, that's nice and
Yeah,
easy. So
but it's pressure that causes that. I
yes,
mean,
yes,
you
that's
can,
right.
yeah.
I applied pressure. I applied pressure to your face, okay, and you staggered backwards. That's fine. We understand why. There's a certain amount of force struck your face. Your head flies backwards. That's wonderful, isn't it? I think we
But
can
the
all
density,
agree.
yeah, we agree. The denser the object, the more pressure.
Oh, touche. Okay,
Yeah.
but I then take an object, this pen, let go, and it goes downwards. But
Because it's got more pressure than the surrounding
yeah, where's that
air
pressure
around
coming from? No one's hit it, no one's pushed it. So
the
where?
object itself. Remember, it's got substance. Substance is physical.
Yeah,
It's pressure.
it's
It's pressure.
yeah.
You can actually take a microscope and you can look into it and you can see it's got little things planted on top of each other, like little scale piece things. I mean, have you
I'm
ever
not
looked
quite
at
sure what you're talking about now, but we know it's made of atoms.
some
It has
microscopic
mass.
scale?
We can
Yeah.
feel it. We can hear it. Okay, so look, I'm holding it with the pen top down. Let go. It drops. Hold it with the pen top
Yeah.
up.
There's a
Oh, it still
density,
drops.
yeah.
It doesn't
It's
go
the
that
pressure.
direction. Why did it decide
Pressure.
that this way I'm going to apply the pressure downwards, but if I turn it this way, I'll still apply the pressure downwards? Why? Is it
Because
an
it's
intelligent
denser.
pen?
It's denser. The air does not have enough pressure to support it.
Against what?
It's like you picking up a baby. If you're gonna let go of it, the baby is going to fall. You are giving that pressure to support the baby in your arms. It's the
Yeah,
same thing.
yeah,
It's
but
literally the air. The air is the surrounding medium. If it's given enough pressure, it supports the density of the object. It's as simple as that. So if there's nothing to support it, where is it going to go? It's not going to go up. It's going to go down because
What?
that's where the pressure mediation is.
Pressure mediation, that's a new term on me. But we discussed that golf ball or ping pong ball or whatever in the airstream of a leaf
The
blower.
magnetic state,
Yeah. So while the blower's off, that ball sits on the blower. You turn it on, you're applying the force, it lifts up and sort of roughly hovers. And then if you turned it up really high, it would go up further. We know that. So, but the reason it sits in one position, apply a force, it sits a foot up, is because we're applying exactly the right amount of force with that blowing stream of air to counteract gravity. If we really turn that blower up, we actually blow it higher. We're countering gravity to a greater extent. We're applying a greater force. But at all times, it's a force up versus a force down. If we turn a blower off, the force down overcomes it and the ball drops. If we turn a blower up, the force up is overcoming gravity to a certain extent.
You would agree higher pressure always has more force than less pressure.
Higher pressure.
It's high to low entropy. The high pressure will always go to low pressure.
Depending on, well, It's going to depend on
It's always high to low.
yeah.
That's
Well, that
entropy.
would be the
Always.
natural tendency, yes. But like with
There's nothing more.
entropy, temperature, you get entropy with temperature. My cup of coffee will be slowly cooling to room temperature. It equalizes, doesn't it?
Yeah,
Yeah.
high to low.
So yeah,
High temperature to low temperature.
but
Everything has
we
a
can
temperature.
change entropy, like a freezer. We're dumping heat out the back to keep the internal colder than the surrounds. So my little fridge there is cooler inside than it is outside. We have reduced entropy by applying the
Yeah,
compressors.
you've actually increased entropy in the surrounding in the universe.
Yeah,
but
yes,
increased
yes,
it-
that's right. It depends. So the system of the fridge, I have reversed entropy, but in the room, I've dumped for some temperature from inside the fridge to the outside of the fridge. Absolutely. So I've increased the temperature in the room slightly as a whole, haven't I?
Yeah.
Yeah.
No,
But
in the room, you've increased it exactly. Yeah.
yes,
In
that's
the,
right.
But that's not what's going on with my point. My point is higher pressure will always go to lower pressure. Open that deep freeze now. What's going to happen with the heat is going to rush into the freezer, and it's going to become warmer again. Because why? Hot to cold, high to low,
Yes.
always.
Yeah, that's where it's. But the point I was making
That's
is
what I'm. My point is,
you can actually reverse it, by a p you can actually reverse the natural tendency. Yes, the natural tendency is without the fridge being plugged in and switched on and a compressor working, the temperature in there, no matter how good the insulation, will slowly equalise with the temperature outside of the fridge. Absolutely correct.
yeah. Okay. Yeah, but back to where we were. That's what I'm trying to say. With the pressures of density, if something has a higher pressure, it's going to have more force. So therefore, if there's something that doesn't have enough pressure to support it, it can't support. That's why if gas cannot support it enough, it means it doesn't have enough pressure to be able to support that object, because the
But
object has a greater pressure.
but
It has a greater force.
when
Not gravity, just pressure.
if you're in I don't know, if you're trying to walk down the road and I'm holding the back of your jacket trying to stop you, okay, if I've stopped you and you're walking on the spot because your feet are sliding, I'm providing exactly the right amount of force to counteract the force of you trying to walk forward. Would you agree?
Sorry, say again?
Right, you start to walk away and I grab the collar of your shirt, okay, and I hold on tight. You keep trying to walk, but you can't get anywhere because I'm holding on tight, because I'm applying the right amount of force to counteract the force of you trying to walk away. Would you agree with that?
Yeah, but if
Okay,
I put
but
more pressure, then I'll be pulling you with me.
yes, that's right. But that's right. And if I pulled harder, I'd pull you backwards.
Yep.
Yep. So it's the sum of the
So
forces. It
the
depends.
the greater pressure
Well,
is
force.
what determines the direction. The
I mean,
greater
yes,
pressure
yes, you're applying force against your feet, against the earth, but you're applying a force forward. I'm applying a force backwards. So it's one of three possibilities. Either I'm pulling with more force, I drag you backwards. We've got equal forces, in which case you're stationary, or you're applying a higher force, in which case you go forward. Yeah, we agree on that, I think, don't we?
Yeah.
Yeah.
Obviously, it's
So yeah, absolutely. So the point is as simple as this: with the dropping the pen, you're saying the air can't support it, but my hand can support it, because my hand, which is nice and stationary, is applying a force exactly equal to the force downwards. If I apply more force, I push it up.
pressure.
So it's the same as vertical as with me and you horizontally, me holding your collar. Either you pull me forward, I pull you backwards, or we stay the same.
Yeah, it's pressure mediation.
Well, I tell you what, we've been
Yeah.
we have been going
And we
quite.
got to end.
I do have a few super chats, and I'm wondering if perhaps we ought to round it off then.
Yeah.
Okay.
Yeah, I also got a super chat. I'll quickly do mine, then you do it. So I've only got one.
Okay.
And you got
Okay.
like-
Okay.
Skeptic 936, $20. Thank you very much, mate. Mr. S, if you'd start telling the truth, you'd have loyal subs like I am to Flatzoid.
Oh, wow. Well, that's all right. I'd like you to point out where I'm lying. I openly would say I could be mistaken about something, as I've openly said during this very stream when, excuse me, Zoid was asking about the pressure inside the Mage balloon, that I'm thinking, do you know what? I can't think. I know that I'm right, but I can't think and I can't explain how. So I'm going to have to find out more about that. So I'm open to being corrected. I don't lie. Okay, I could be wrong, but I don't lie. Is how I'd answer that.
I think you honestly believe what you say.
I
Just like
do.
you believe
I do.
say
I think
what
I have the evidence to support it. But yeah, I'm being honest, and I hope that that's the position you're coming from too, Zoid. I do.
Remember, I told you before, what a boring life it would be if everyone had the same views and opinions.
Well, this is true, but we certainly wouldn't have, what was their names? The two that were out, Godzilla and Godzilla, arguing over their names. Okay.
Rivalry.
Right. Well, I've got a couple of chats as well. Sorry, let me scroll down. Where were we? We said about the paint can. Oh gosh. Okay. Ted Iacocca says for 199, can you explain the different pressures 2 meters apart on Earth? Yes. So why can you get a pressure reading? I mean, the case of that Burj Khalifa, it was within a few hundred meters and it dropped quite a few hectopascals. Why doesn't it equalise?
Less amount. Less. Remember, like I said, you got the less amount. Therefore, it equals. Remember, in the system, it's a very large open system, so it's dispersing what on the horizontal. So that's why you got that little bit of gradient, you could say, in that 2 meters.
Okay. Ted also says, what is density then? Oh, I don't think we read this. Or did we read it? What is density? He actually asked two. What is density, and then and what is acting on that amount of substance?
What is acting on the amount? The density is causing the pressure because it's compact in the object, so it's causing the pressure.
Okay.
Just like that's what I wanted to also say. Just like if you take, just quickly, if you just take a let's say a 5 centimeter brick, and it has a weight on the scale that causes pressure. Now, if you take it and you have the same type of density brick, but it is now 10 centimeters, it's going to still be the same density, but way more because you got more substance in that system because it's per cube. The density is only per cube, but because you're putting more of it, it's causing a greater pressure on the scale.
So what I would say is what you're describing, with other words, is mass. That's how
pressure.
I do. We're going to just have to
yeah, but
disagree.
I think mass, according to you guys, is it's like inertia. It's actually the same as inertia, as far as I know.
Okay, I've got Ted Iacocca super chat saying missed my chats. Ted, I mean, I had just read a couple. They are getting. You've super chatted a lot, which I really appreciate. But I'm pretty sure that I've covered all the super chats.
Most of them, yeah.
I have to.
If I saw, I would have let you know, and I didn't see any.
No.
Again.
I have to use the Discord and IFTT because the super chat thing on YouTube is so terrible, and for a long time, probably for about 2 years, the system on Streamlabs hasn't picked up super chats for me. It just stopped working one day and it's never worked since. We did do that. Oh, Ken Eaton says, let's see the predictive calculations for density.
You can go to I Can Science That. I think he did it.
So what?
He did the equation.
Based on the density, you can calculate what? The speed something falls?
Magnitude. Or? Yeah, the magnitudes and everything.
Okay. Ted Iacocca also says air pressure comes from all sides. Yeah, so this pen. So what's the yeah, that's interesting actually. This pen I said, why does it fall down? You said because the air below can't support it, and I said, well, why doesn't it fall up? So what's the difference in the air pressure here to here? They're about just under a centimetre apart.
They're the same, but like again, it can't support it. If you have to put a leaf blower underneath it, it's going to blow it up because you've caused a higher pressure to push it up.
So it falls because it's not supported. And the 2-word question I have is, against what?
Air, the greater pressure. Remember, you've always
but there's air. There's air here. There's air there. Why doesn't it pick any of those directions? I would say the reason it wants to go that way is because there's a force pulling it down. Right now, I'm applying enough force to hold it up. If I open my fingers, I'm not supporting it against that downward force.
The only downward force is the object itself having the greater pressure.
Okay. Well, we're obviously going to go round in circles here, Zoe. I do want to get through the last of these. Ted Iacocca again. I was talking about your entropy and so on. If high always goes, and pressure, beg your pardon. If high always goes to low and low is up, why fall down? Good point.
We just answered that.
But we know with the pressure gradient, the air pressure here is slightly lower than the air pressure here. So why doesn't the high go to the low?
You're contradicting your statement 2 seconds ago where you said it's the same pressure right on top of it.
I said, yeah. I mean, Technically, there's a gradient. It will be different. But even just air movements, because of the heat of the equipment, will be changed. That's so close. But okay. Who's this? Oh, Now Pinion. Now Pinion. Good evening. Now. By the way, have we sufficiently promoted JC Clark's latest song featuring both Mr. S and FTFE rapping? It needs more views.
Did you guys rap?
We got it. Where was it? So, someone posted if you just bear with me a second, someone posted a link to it. It was something me and Fight did about a year ago, and now I think can someone post a link to it? There is a rap, and I can't see where it is right now.
While you're looking for it, I'm just gonna say Skeptic 936 $5 super chat. Mr. S, I love you, bro. Even though you are deceived, it's all good.
That was from who?
Skeptic 936.
Well, thank you very much, Skeptic. I appreciate that. Just because I disagree with someone doesn't mean that I dislike or hate them or anything like that. And I do appreciate the thought. That's very kind. I can't see this video. So someone posted it on my channel, on my Discord channel. Any mods? Oh, there we go. Now Pinion's just posted a link to it. Music video featuring Mr. S and Fight the Flat Earth. So yeah, go and give it a watch at some point. That would be very kind. So I do want to catch up with those last. So that was Now Pinion. Ted again. High pressure at the surface of the Earth should then force objects up Flatzoid. Your ideas are opposed to themselves. That was $4.99 chat. Thank you very much for your kind generosity tonight, Ted. So
and I should ask the same. Why up? Why would you expect it to go up?
Because you would be moving into an area with lower pressure.
But underneath is still lower pressure. Remember, like I said, the object itself is a higher pressure than everything around it all the time.
Okay.
You need something to support it. I said against. That's where the disequilibrium comes in. It's disequilibrium.
Yes, I have no problem with the fact that this pen is a different density than the air surrounding it. I have a problem that you need a force to move an object, and you need a direction, a vector. The vector is downwards, always downwards, unless you provide, like in your leaf blower example, a force upwards. It's moving from one level of atmospheric pressure to a higher level of atmospheric pressure. So it's moving from an area with not much support to one with more resistance. That's the point. He's making the same point I made.
Yeah, disequilibrium.
And I've had another one from Kenny Eaton for $1.99. Why does weight, vary with latitude? Good question. Why does
is
weight? Yeah.
Yeah.
If I took an exact 1 kilogram weight here in the UK, if we then carefully see, I'm sorry.
Talking about the Earth.
Absolutely. If I went to the equator, it would weigh slightly less. How can that be?
Did they use the same scale? Did they tear the scale? Did they make
Well,
sure
yeah,
everything is
yeah,
right?
everything.
The pressure, was the temperature the same? You know how a scale works, correct?
You can. It's like with the scales for gold; they have to be calibrated for your latitude. Otherwise, people would be getting ripped off. The point is, if you weighed that kilogram at the North Pole as exactly 1 kilogram, by the time you get to the equator, it will weigh, let's say, 998 or. Okay.
It's like very small amount.
Yes, it's a small amount. And then you go further south. For some reason, it gets heavier again until you reach the pole, when it reaches its maximum of 1 kilogram again.
Many reasons that could cause it. Could be magnetism, could be temperature, could be pressure, could be many things.
Yeah, but
the same scale you try and take. I know, I work with scales every day. If you just move the scale, you can tear it. It's not going to have the exact same measure, even if you calibrated it. And you move the scale, the calibration is out.
So what I would say is a very, very good point, Flatzoid. And if you were doing that as an experiment, those are all possible. What's the word? They're possible variables that you need to move out. Oh, I'm at the North Pole and it's 0 degrees, but now I'm at the equator and it's 35 degrees. I wonder if that makes a difference. So you would have to allow for temperature. Perhaps you weigh your scale at the North Pole in a room that's heated to 35 degrees to rule out the temperature difference. That's it. You have to rule out other factors that might be affecting your experiment. Temperature, pressure. I don't know what others. I'm not specialised in that. Thank you very much. Someone's just posted a conflating variable. Justin Franks, thank you. So you're absolutely right. If I said, look, Zoid, I weighed this at the pole, it was 1 kilogram. I weighed it at the equator, it was 998 point whatever grams or whatever. There you go. And you say, but it's warmer at the pole. You're quite right. We need to rule that out, either by, well, perhaps you do it both ways. You measure it in a 35 degree room at the pole and at the equator, or you measure it at the pole. Oh, look, it's -7, and then you do it in a freezer room at the pole, at the equator, with the temperature set to -7. You rule that out, so we know the temperature's the same at both, and it makes no difference.
Let's say you control all those variables.
Yeah.
You take even the same scale width. You've taken a 5 kilogram weight, like we usually use to calibrate our scales. You stick it now, you've calibrated the 5 kilogram scale, you've taken an object, you've measured it. Okay, I've weighed it at 2 grams. Taking the scale, taking the weight with everything. You have to literally you have to tear the same scale with the same temperatures, same pressures, same everything, with the same weight, and you have to get the same tear. Once you have that teared value with that, if you have a difference, there's so much confounding variables that make it change. As I said, I can literally move my scale and do that just 10 meters away from me, and I can get a different reading.
No, listen, I totally understand, which is why science, accurate science, is so difficult. If I used a set of kitchen scales, they're just not going to be accurate enough. Yeah. And as you say, different air pressure, different temperature, moving it from one place to another could knock the tear out slightly. Of course. So if I was a scientist, and that was my aim in life, was to test this hypothesis. If the Earth was a rotating sphere, then I would expect that weight to that kilogram mass or 5 kilogram mass to weigh less on the equator. But I've got to rule out all those conflating variables.
Yeah.
So yeah, it would be difficult. I don't deny it.
Yeah.
Some are easier than others. It'd be relatively easier to adjust for the temperature, but some of the other things, absolutely, it'd be really, really difficult. But that's why science can be very expensive, very hard.
Skeptic Andrews sent another $10 super chat for you. Thank you, Mr. S, for joining us today. Much respect despite my comments.
Well, thank you very much again. And your comment and the last one were both very, very nice. I don't know if you said anything that was not so nice earlier on, but to be honest, the comments that have come from Zoid's channel, there's been nothing nasty. I have no problems with any of them. No problem with any of them. I'm going to read one more, I think, and then because I'm sure you got to get on, and I'm going
to open up the show as well. So
okay, after show, interesting. I'll try and catch up with that tomorrow. At midnight, so in just under 2 hours, I'm going on as a guest of Fight the Flat Earth. He's taking on a Discord server, and I'm joining him. No idea even right now which Discord server it is, what the topic is, so that's going to be interesting. But then there was no specific topic tonight, was there, Zoid?
I'm in the future. I'm already on Sunday.
Are you? Time is it's Sunday. Get yourself to church then. But before you do, answer this super chat from Andrew Johnston, $2.99. Why does weight vary with altitude?
Precious.
And not
change. Remember, when you take something in a vacuum, it's going to have a different weight to something that's inside a pressurized container. And altitudes also have temperature differences as well.
But it happens to follow the formula for gravity, you know, depending on the relationship between the two masses and the distance to the centre of the mass and so on. Inversely proportional to, you know.
But clouds don't follow that, though.
Sorry?
Clouds don't follow that. Clouds don't fall.
Well, of course they do. It's called rain.
No, the water falls. The clouds itself, as a water vapor in the air, doesn't fall.
There's water vapor, and as those droplets
become denser,
as they condense, for a while they'll carry on swirling around because they're still really small droplets, and the force of the air is enough to fight gravity until their size and mass gets too much for the air currents to support them, and then they drop and you get wet.
Why do you get heavier clouds higher up there?
What do you mean heavier
Sometimes
clouds?
you get clouds that are heavier.
If they're bigger, are you talking about very big clouds? Yeah, but then it's also going to depend on the air movement. You think of something like, is it cumulonimbus, the great big storm clouds, and they're bubbling up because there's more force and movement. You've got that. That's why with storms, things like hurricanes, they require temperature differentials to provide the force in order for them to grow.
Owen says it's not water vapor.
Sorry, Arwin.
Water vapor.
Sorry, was this Arwin?
Yeah, Owen's there. I thought it was water vapor. So if I was wrong, I'm sorry. I do believe it's water vapor. What is clouds then? This makes me think. Let me check it up. What's water vapor?
Sorry, what's he saying?
As far as I knew, clouds are water vapor.
I see that Owen says, stop giving Mr. Sensible ground to treat you like a retard. Well, I think we've actually had an interesting discussion. Yeah. We've not agreed on everything by a long chalk. And Zoid has said he's going to look into this experiment with the light sliding along his garage floor with some markings at my request, and that will be interesting. And I'm going to look in more about this business of the air pressure internal to blue.
Called water vapor. There we go.
Yeah. And Bob the Science Guy asked, well, what do you think clouds are, Flatzoid?
Water vapor, as I said.
Yeah. So I'm not sure.
I don't understand what's his problem.
Oh, he says you cannot see water vapor. Clouds are not vapor. Is he thinking of steam?
Just another phase. Water vapor is just another phase. That's all. Steam is gaseous, not gas. Yeah.
Well,
this is another debate for something else, probably.
It is.
But yeah.
Oh, right. Colon in my chat is just saying clouds form when water vapor in the air cools down and condenses on dust or other particles, process called condensation. So I guess what Arwin's saying is the vapor itself is invisible until you get all the little particles of with condensed water around it.
Well, I'm going to look more into the clouds thing then, because as far as I know, I was taught it was water vapor.
Yeah. Anyway, Ted Iacocca says, can you get me on FTFE server argument? I'm a member, $1.99. Ted, it's a debate that fights
24/7, I think.
to be honest, I don't even know.
Because I know you usually go 24/7 to do the debate.
He's also posted on another one, I think. I'll just post a link to it there. It starts at midnight tonight, UK time. It just says an entire Discord server of flat earthers. Yeah. So he's invited me on to just join him. Ted, you can always drop Fight a message, DM him via his server if you want to request something like that. It's not his.
And I'm sure he wouldn't mind.
Yeah, it's not my server. Yeah, like I said, I don't even know where it was, and I was invited. So, by all means, contact Fight. Flatzoid.
Yeah. Thank you very much.
It has been a pleasure.
Yeah, we must definitely do it again. Next time I think we'll work out a topic next time.
Yeah. Although I think it has worked out quite well. And I'm sure that lots of people on your server have been gritting their teeth at some of the things I've said. And I know that people on my server are gritting their teeth at some of the things that you said. But I think that's part of the fun.
But that's normal. Yeah, it was fun. And I mean, I really liked the chat with you. Like I said, it is nice and chill. It's not like we swearing at each other and going down each other's throats.
No.
We agree to disagree kind of thing.
And listen, I honestly can respect that. I'm going to say it. I can respect someone handling yourself as you've handled yourself tonight, but I would never ever respect someone like, I'm going to say it, Nathan Oakley and his hateful abuse. Okay, I put you in a totally separate class. Okay, take that as you will. You don't have to take. I don't know what you think of him. I'm not trying to get you to speak out against him. I'm just expressing my opinions.
But everybody enjoyed it, so
yeah, cool.
Enjoy.
Okay, thank you very much, then, Flatzoid. Keep in touch, and we'll do this again sometime not too distant. Yeah.
Yeah, thanks for inviting me. I really appreciate it.
My pleasure.
Because I stream it every night, so if you just let me know maybe about a week before the time.
Yeah, and we'll try and decide on a subject. That'd be good.
Yeah, definitely.
All right, thank you very much.
And then I'm just going to give a shout out to all your guys on your channel. Yeah, thanks for coming, guys, and my chat as well. Thanks for coming. You guys are awesome.
And do you have anything to shill out about your channel? To my viewers, anything you got coming up that you want people to know about?
Yeah, look out for that video I'm talking about with the why space is fake kind of thing. Why space travel could be fake.
Okay.
Yeah.
Okay. All righty. And from my point of view, I've already mentioned it. From my point of view, I've got this thing coming up with Fight the Flat Earth on my channel. On his channel, and probably somewhere else, but it's on his channel, not on my channel. I have posted the link in my live stream. Zoid, because it's not to me, if I just open chat at the side and send you that link, are you able to post? Have you got that in the side chat?
Yeah, I got it.
If you could if you don't mind, post that. That's Fight the Flat Earth discussion with the Discord server that I'll be on as well.
Oh, there we go. Yeah, I'm copying it and I'm sticking it in my chat.
Okay, lovely. Thank you very much.
Okay.
Okay.
There we go. Yeah, then the guys have something to keep themselves busy.
Yeah. And they can see more of me, which can't be bad. Okay, you take care.
You too, mate. Thank you very much.
Thank you. Bye-bye.
Till next time. Cheers.
You too. Bye-bye. And is he out? He's out. Well, I hope you all enjoyed that. I did. Yeah, there's rather a lot I disagree with that he said, but we're not really expecting any differently. But at least it was a civil chat, a bit of a laugh. And even he was giggling at jokes at his expense, and I was jokes at my expense, and that's fine. As I've posted in there, I've got this debate thing. I'm sort of Robin to fight Batman tonight, I think, on his discussion with the Discord server. Don't know how that's going to go. That's in an hour and 3/4, so I'm going to take a nice little... Oh, what's happened? It says I've left the meeting. Oh, no, I'm showing his stream. I'm not sure how it's going to go. Hopefully it'll be fun. Oh yes, it's not advertised with me on his channel because it was waiting for confirmation from me, and I wasn't sure how it was going to go, how tired I'll be, but I'm up for it, so I'm going on there for midnight. So thanks again for all the super chats. I do appreciate each and every one. If I have missed any, my deepest apologies. I really, really try hard not to miss any of them. Dr. Nimrod, hope to see you there then. Mark, you are lovely and much kinder than he deserves. You're going to make me go all teary now. Thanks, Mark. Appreciate that. Appreciate it. So take care all. See you soon. Stay sensible.
Mr. Sensible, Mr. Sensible, bring me some cheese, and get me only the best if you please, best if you please. Here are some flowers, let me display them. Yea, Dr. Warner, you have gone all slay them. Mr. Sensible, you are a man. Every subscriber is a faithful fan. Bring your logic and your cheese. Mr. Sensible, help us out please. Mr. Sensible, I needed proof of gravity, so I jump off the roof. It hurt not let me go further. Why was I ever such a dumb flat earther? Mr. Sensible, I'm such a clown. I am the laughing stock of the town. Bring your logic and your cheese. Mr. Sensible, help me out please. Mr. Sensible, bring me a sphere, to which the waters of the oceans adhere, have explanations, but let me be candid. So clear that all the travelers understand it. Mr. Sensible, please hear my call. The earth is not flat.